Okay, are we back? Are we live again?
That the alternate airport should have at least
Alright, we are back.
1,000-foot cloud ceiling and 10
I have no idea
kilometers.
what happened there. Literally, it's like started lagging like crazy, and then like everything froze and died.
6.2 miles of visibility, which was clearly not met in this case. Now, to be perfectly honest here, the pilots should have caught this when they checked the dispatch paperwork, because making sure that we have a suitable alternate airport is a really important part of our pre-flight duties.
Yeah, like literally, what's the point? Like, what's the point? Like, okay, say like we're going to airport A, and we found that doesn't really have good weather. We could say that, and then the airport we selected to divert to was even worse. Like, what's the fucking point of diverting because the weather in airport A was too bad to an airport where the weather was worse? Like, what's the point there?
But overall, it seems like everyone in this scenario was just going through the motions, so this important question was never even raised. If the pilots would have noticed the poor weather, they could have easily changed the alternate to Buffalo or Syracuse instead, which did meet the weather requirements, but that never happened.
Bro.
Now, on top of this, the pilots could and should have requested updated weather information whilst en route, but for some almost inexplicable reason, they didn't do that either. Investigators later reviewed communications with Avianca Dispatch and every air traffic control facility along the flight's route, but there was no record anywhere of any request for the latest weather in JFK made by the flight. Now, we don't know why the crew never performed this crucial part of their duties, but there might have been an element of complacency involved. And that could also explain why the flight crew never asked about the traffic situation in New York either. You see, Avianca had a contract with a dispatch center in Miami that the crew could have called to request this information, but they never did that either. And according to dispatchers who worked there, they rarely heard from any Avianca crew at all. This could suggest that the culture at Avianca was not really encouraging pilots to be very assertive and to take control of their own circumstances, and that is something that we're going to see again as this story continues. Anyway, for several hours, Flight 052 therefore continued uneventfully northward. Eventually, they passed through the Miami, Jacksonville, and finally Washington ARTCC, which is where they suddenly run into the back of the massive queue inbound to JFK.
Oh shit.
At time 1904, the Washington ARTCC placed Flight 052 into a holding pattern over Norfolk, Virginia, a full 250 nautical miles south of the destination. And that was because not only were all the holding points in the New York ARTCC area already
I had to do it.
full, but so were the northern holdings in the Washington sector as well. After holding over Norfolk for 19 minutes, Flight 052 was eventually cleared to continue to the Bolton
McDonald's better.
intersection near Atlantic City, New Jersey, where Washington ARTCC put them into a second holding pattern at time 1943 in order to await space to open up in the New York sector. During this period, the pilots were cleared several times to descend, which likely kept up the impression that they were at least making some progress. But at time 20:09, after holding at Atlantic City for 26 minutes, the first officer finally asked Washington for information about any delays into Boston. And this was the first indication that the flight crew was maybe starting to be a little bit concerned about their situation.
Yeah, I bet.
The cockpit voice recorder unfortunately only captured the last 40 minutes of the flight, so we
I thought it was the last 30 or something.
don't know what the crew were discussing at this point or whether they were actually discussing to divert. But in any case, in response, the Washington controller stated that Boston was open and accepting flights and that they now could expect an additional 30 minutes of holding in New York airspace for JFK. At this point, Flight 052 had already been holding for 45 minutes, which is quite a long time, so 30 more minutes on top of that should have definitely started to raise some alarm bells about their fuel state.
But like this moment.
Now, of course, things weren't quite the same back in 1990, but the way that we do things today is that we, as a crew, will agree on a minimum diversion fuel level. And if we predict that we will start to get close to that diversion fuel level before we start our approach, then we might decide to divert right away, even before attempting an approach to our destination, especially if the weather is bad.
Yeah.
We can also decide to commit to the destination and use our diversion fuel for holding, but only if the weather and situation is so good that a landing is highly likely. Now,
yeah, because if you get near to the diversion fuel, and you're on approach for the airport, and the weather's bad, even if you're literally right about to land, you might have to divert because you might have to do a go around, and that'll eat up more fuel.
Calculating the expected fuel levels
might not
at
have.
any different point, including the diversion fuel required, would nowadays be done using the flight management computer. But on Avianca's 707s, it would have instead been the job of the flight engineer to do that. But there is absolutely no evidence that this was being done in this flight at all. Now, if a diversion fuel level isn't established, well, then you run the risk of letting yourself wait too long at your destination, and if the weather then turns out to be terrible, you might find yourself painted into a corner with no way out.
Yep.
At time 2012, Washington ARTCC cleared Flight 052 to continue north into the New York ARTCC, where they were subsequently cleared to the Cameron intersection, 39 miles south of JFK. Cameron was the point where JFK-bound aircraft were normally handed over from the ARTCC to the TRACON. But on that day, because there were more aircraft in the airspace than the airport could handle, aircraft were instead stacked up in holding patterns over Cameron at multiple flight levels.
Damn.
Now, because the TRACON's job is to sequence aircraft for approach, they don't hold aircraft in their airspace. Instead, they only accept a new aircraft when space has opened up in the landing queue. And the TRACON also has to keep a certain distance between aircraft in the approach corridor so that flights don't start catching up with each other when the plane in front starts to slow down for the approach. On this day, there was also a strong wind from the south, which meant that aircraft inbound from the south would have a strong tailwind at first until they turned around to approach runway 22 left, at which point that tailwind would become a headwind, resulting in a huge reduction in ground speed. So because of this, bigger separation was also required in the initial approach corridor, extending the delays even further. This meant that when Avianca Flight 052 finally arrived over Cameron, they were now the last ones in line to be fed into the TRACON.
Bro.
And when you have, let's say, 8 airplanes ahead of you and it takes each of them 5 minutes to cover the separation distance before the next plane can leave the hold, well, then you're looking at a minimum of 40 minutes delay. All of that was apparent to the TRACON controllers, but not so much to the Avianca crew, who seemed to have really had no idea of just how bad these delays actually were.
Oh no.
At time 2018, when Flight 052 arrived over Cameron, flying at 14,000 feet, the New York ARTCC told the crew to expect further clearance at time 2030, meaning in about 12 minutes. Now, most likely the flight crew believed that this was the time at which they would finally be cleared for the approach, but that was not what an expect further clearance time actually meant. In fact, the controller had no idea when Flight 052 would be cleared for approach, but they did expect to clear them to descend further at 2030. It's likely that the Avianca crew did not understand this, and later Colombian investigators pointed out that if an expect further clearance or EFC time doesn't refer to the time when the plane will be cleared for approach, then what was the point of that EFC at all? And I kind of agree with that.
Yeah.
In fact, that's likely why we don't use EFCs anymore. Instead, controllers today only give us an expected approach time, or if that time is unknown, they will say something like indefinite or undetermined holding. Now, if at this stage the crew of Flight 052 had been told to expect indefinite holding, they might have decided to just divert immediately towards their alternate, or at least to start making some type of contingency plans. But now that didn't happen. And if the pilots would have requested the latest information about the conditions at JFK, they would have learned that the weather was now way worse than expected. In fact, it had a visibility hovering right around their landing minimums, and it was combined with strong winds and rain. In fact, at time 2035, JFK informed flow control that 20% of all flights that attempted to approach runway 22 left had been forced to go around due to low visibility. So this was definitely not the time to commit to that specific airport. But here it seems like the pilots fell into the trap of believing that an approach to JFK was right around the corner, and that once they were cleared for the approach, all of their problems would be solved. As their first EFC time of 2030 approached, the controller provided a new EFC time of 2039, while also clearing the flight to descend down to 11,000 feet. Now, the crew accepted this without a protest, probably figuring that they could still wait 9 minutes more, and besides, they were being given further clearances, so clearly they were making progress, right?
No.
Well, time 2039 came and went, with no further clearances issued. It was around this time that the flight crew probably started to become really concerned about their fuel state, when in reality they should have been thinking about this for at least an hour at this point. They had now been holding at 3 different locations for a total of 1 hour and 9 minutes, and that meant that they had used up all of the fuel for the en route portion, plus most of the contingency fuel and diversion fuel that they had on board.
Oh no.
In fact, just to land at JFK would now require them to dip into their final reserve fuel, which is never supposed to be used except for in a real emergency. Today, if our calculations show that we're going to have to use any of that reserve fuel, we must immediately declare an emergency to air traffic control using the phrase Mayday, 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 fuel. By doing that, we unambiguously tell air traffic control that we need to move every single other aircraft out of our way so that we can land immediately. And there were actually 3 words that could have gotten this response from ATC at the time, and those were emergency, mayday, and also pan pan.
That's fine.
At this point, the Avianca crew were within rights to use any of those terms, and if they had, well then the outcome of the story might have been very different. But instead, the crew now kept waiting past their expected further clearance time until time 2044, when the New York ARTCC...
Wait, Becky, still confused. What made you ask if I was okay? Just wondering.
He transmitted a new EFC time of 21:05. At this point, the pilots must have realized that if they didn't get any further clearances before time 21:05, they might actually run out of fuel even before reaching the airport. So, in response to this new EFC, the first officer now transmitted, well, I think we need priority. Now I want to pause here for a second and discuss the use of this word, priority. You see, priority does confer a sense of urgency, but in general, controllers would assume that if the situation was an actual emergency, well then the pilots would instead use one of those 3 words that I mentioned before. This meant that if you requested priority, you might receive some favorable treatment, but the controller probably wouldn't drop everything to get you to the runway as fast as physically possible. But Boeing documents related to fuel management on the 707 actually advised the pilots to request priority from air traffic control whenever they were operating with low fuel. And other Avianca pilots testified that their colleagues who had undergone training directly with Boeing, which included the first officer of this flight, came away with the impression that the word priority in a low fuel situation would result in the same air traffic control behavior as the word emergency.
Oh my god.
Now, this is super important to understand because it actually explains a lot of what happened next here. In response to the first officer's request for priority, the New York ARTCC controller now asked, how long can you hold and what is your alternate? The first officer responded, yes sir, we're able to hold about 5 minutes. That's all we can do. Now what he meant here was likely that if they didn't start their approach in the next 5 minutes, they would not have enough fuel to reach the runway, but that's not exactly what he said. In response to that, the controller asked, what's your alternate? To which the first officer replied, we said Boston, but it's full of traffic, I think.
Yeah,
The controller asked him to repeat that last message, and the first officer then said, it was Boston, but we can't do it now. We run out of fuel now. As this was happening in the ARTCC facility, a handoff controller, whose job it was to arrange handoffs between the ARTCC and the TRACON, had heard the first officer's request for priority and immediately called to ask the TRACON if they could take Flight 052 in. Now, while his colleague continued speaking with the first officer, the handoff controller said to the TRACON, Avianca 052, just coming off Cameron, can only do 5 more minutes in the hold. Think you'll be able to take him in, or should I set him up for his alternate? And in a tragic coincidence, he didn't hear the first officer say that he could no longer reach Boston, since he had already shifted his attention over to calling the TRACON at that point.
Oh my god.
As a result, the handoff controller assumed that when the first officer said that they could only do 5 more minutes in the hold, he had meant that after 5 minutes they would have to divert to their alternate, when he had actually meant that if they held for more than 5 minutes, they might not even reach JFK. And then, in a second critical miscommunication, the handoff controller didn't advise the TRACON that Flight 052 had requested priority. Because of all of this, the crucial knowledge that Flight 052 could not reach its alternate was now completely lost in the transfer. Less than a minute later, the New York ARTCC cleared Flight 052 to exit the holding pattern and to contact the TRACON, and within moments later, they were out of the holding and proceeding in the direction towards JFK.
Okay, good.
This likely convinced the pilots that they were now being given priority, when in reality they actually weren't.
Oh my god.
In fact,
Just
the
give him
TRACON
priority already,
controller had simply
goddammit.
decided to take Avianca next, and he didn't think any further special action was actually needed beyond that. And that misunderstanding was also tested just a few minutes later, shortly after the start of the cockpit voice recording. You see, because Flight 052 had been taken out of the holding early, they didn't have the appropriate separation from the aircraft ahead. So at time 2054, the TRACON instructed them to turn right heading 220, I'm gonna have to spin you, sir. And that was, for all practical purposes, another holding pattern. Now, if Flight 052 had declared an emergency, the controller would have obviously ordered other planes out of the way instead of giving them an orbit at this point. So this should have been a clear evidence to the pilots that they were not receiving the type of assistance that they needed. But instead of protesting, they just accepted it without any further questions or calls.
SMH.
Now, it has to be noted here that the captain either couldn't understand the controller's transmissions due to a language barrier,
Oh lord.
or he wasn't wearing his headset or something else.
Bro, what the freak is happening?
else, because the first officer had to repeat every single instruction back to him. So in this case, the first officer simply gave him the heading that they had been cleared for without explaining what the controller was actually doing or why. And with the autopilot inoperative, the captain would have been hand flying, which probably required the majority of his attention. You see, the autopilot is a workload reducing device, and when you don't have it, the extra workload of flying the plane displaces the ability to direct attention towards other topics, like analyzing the air traffic control and fuel situation or listening to transmissions in a foreign language. So in this case, the captain simply flew the plane through this orbit as though there was nothing else that he could do about it. Now that maneuver cost Flight 052 about 6 minutes, which, if you recall, was longer than the pilots said that they could hold for. Now, if the ARTCC had told them to wait for 6 minutes, they might have said no, but now they likely believed that they were being given priority handling, because they must have somehow rationalized that this was the fastest way to get to the runway, even though it obviously wasn't.
Oh no.
Anyway, during the orbit, the controller also gave them some more bad news. There was
Aviation YT, I have wind shear for you at 15, an increase of 10 knots at 1500 feet, and then increase of 10 knots at 500 feet, reported by 727.
Wind shear reported on approach, with a 10-knot change in wind speed at 1500 feet and then again at 500 feet. In the cockpit, the captain now asked, "What is he saying? Wind shear?" To which the first officer replied by repeating the controller's transmission in Spanish.
He's advising us that 727 reported a wind shear condition during approach at 500 feet, exceeding the speed of 10 knots.
After the controller had told them about the wind shear, the pilots tuned into the automatic terminal information system to copy the latest weather. And that indicated that there was now...
Oh god, let me read this. Kennedy Airport Information Zulu 0150 Zulu. Weather indefinite, ceiling 200, sky observed visibility 1 quarter, light drizzle, fog temperature 48, dew point 47, wind 190 at 17 altimeter 296, 9. Approach in using ILS runway 22 left, departure runway 22 right. Notices to an airman, soft control system is out of service, replaced by the Amber Hold Bar system. Center weather advisory from Allentown to 20 miles southwest of Kenton at Kenton. A solid line of heavy showers and thunderstorms moving northeast 40 knots should reach Philadelphia Airport.
An indefinite
God damn,
cloud
that is a
ceiling
mouthful.
at 200 feet, visibility of 1/4 of a mile, light drizzle and fog, and winds out of the southwest at 17 knots. So basically, dreadful conditions in which a successful landing was definitely not guaranteed. The pilots were well aware of their dire fuel situation at this point, because the cockpit voice recorder now captured the flight engineer reading out the abnormal procedures for flight with less than 1,000.
When we have with 1,000 pounds less than
pounds of fuel in each of the 4 main tanks. You see, when the tanks are nearly empty, changing pitch too sharply can cause the fuel to slosh away from the fuel pump inlets, resulting in engine flameout, so the crew had to be careful here. By now, a mounting sense of dread was probably building up in the pilots' stomachs, and things were about to get much, much worse.
Oh no.
For several minutes, Flight 052 now received normal handling, with progressive clearances to lower and lower altitudes, as well as vectors towards the final approach, just like any other plane in the landing sequence. During this time, the pilots still insisted to themselves that they were indeed being given special accommodation. As the first officer said, "They accommodate us." And the flight engineer stated, "They already know that we're in a bad condition." The first officer also attempted to reassure the captain by adding, "They are giving us priority." But in reality,
they're not.
They weren't.
Yep.
At time 21:11, the TRACON final controller cleared.
You are 15 miles from outer marker, maintain 2,000 to establish on the localizer, cleared ILS 22 left.
Flight 052 to intercept the ILS approach for runway 22 left, and then instructed them to contact the tower. Now, they soon successfully intercepted the localizer to align with the runway, and then started preparing to also intercept the glide slope. This would be the hardest part, because with no autopilot and no approach mode on the flight director, the captain would have to, like I mentioned earlier, fly the approach using only raw data instrumentation. With reported wind shear, low visibility, manual flight on raw data and critically low fuel, this was almost certainly the most difficult approach that this captain had ever flown. And it was definitely the one with the highest stakes.
Lock in!
Their fuel at this point was so low that if they didn't land on this first attempt, there was almost no chance that they could complete a second approach. So they had to get this approach right. Inside the cockpit, the captain continued having difficulty processing what his colleagues were saying, and at one point he even snapped at the first officer and told him, "Tell me things louder, because I'm not hearing it." And that was a clear sign that he was under extreme stress at this point. At time 21:18, flight 052 finally began to intercept the glide slope, while the pilots progressively extended the flaps to their maximum setting of 50 degrees and also lowered the landing gear. It would later turn out that flap 50 actually wasn't allowed with the special hush kits that this 707 was equipped with due to noise, and the extra drag from this flap setting likely made the captain's job even harder. Ahead of them, another aircraft now encountered a significant wind shear, worse than what the controller had previously reported, but this information was never passed on. In the cockpit, the captain was trying to follow the glide slope, but he did so with a rate of descent that was too high, likely because of a 60-knot headwind that was causing them to have a lower ground speed than normal. And because of this, they now quickly began to descend below the glide slope. The first officer called out corrections, to which the captain ended up overcorrecting, which is very easy to do when you're flying raw data. Remember, he didn't have a flight director telling him how much he should be pitching up or down as he normally would.
Oh no.
At time 21:20, Kennedy Tower cleared Avianca Flight 052 to land.
Avianca 052, 2 to the left wind, 190 at 20 cleared to land.
Reported that the wind was now 090 degrees at 20 knots. So, with that 60-knot headwind that they had at their current altitude, this meant that somewhere in the next few minutes they would experience a 40-knot decrease in wind, in what's known as a negative wind shear. A positive wind shear tends to increase the airspeed and lift the plane up, so a sudden loss of headwind would have the opposite effect, causing airspeed to decrease and the plane to descend instead. Continuing to monitor the instruments as they passed through 1,000 feet, the first officer repeatedly warned, "Slightly below glide slope," and the captain repeatedly responded by overcorrecting above and then back below the glide slope, obviously struggling to follow the raw data indications.
Come on.
"Below glide slope," the first officer cautioned again. "Glide slope!" And then suddenly, at time 21:22, the headwind decreased by 30 or 40 knots in a matter of seconds, causing the airplane to descend rapidly. "This is the wind shear," the first officer exclaimed, accompanied by the ground proximity warning system bursting into life, blaring out, "Glide slope."
Whoa, up, think rate.
That's a different voice than I remember on Boeing.
500 feet, the first officer then called out. They were now getting very low on the approach. A mile and a half short of the runway, they descended to only 200 feet above a residential neighborhood.
Oh shit.
The ground proximity warning sounded 13 separate times as the flight crew now desperately looked out, searching for the runway through the rain and fog. But with a cloud ceiling at 200 feet and only a quarter of a mile of visibility, they were unable to spot it. In the cockpit, there was now desperate shouting as the captain exclaimed, "The runway, where is it?" And the first officer repeatedly replying, "I don't see it, I don't see it." And it was at this moment that the captain came to the horrible realization that they wouldn't be able to land. He had no choice but to go.
Oh lordy.
Around and hope for the best. So he now made the fateful call. Give me gear up.
What do you watch me from?
At this point, Flight 052 only had about 10 minutes of fuel remaining, so even if they had immediately turned straight back to the outer marker and repeated the final approach, it was questionable if
Will you watch my stream in Minecraft?
they could have made it. But if they wanted any chance of survival, they had to at least try. Try to get that aircraft quickly onto the approach again, but that's not what happened. As the captain started to go around, he told the first officer to request another traffic
Ain't no way, boat. How did you manage to do that?
pattern, while the flight engineer warned him
How?
to be smooth with the nose to prevent fuel slushing and engine flameouts. Executing a missed approach, Avianca 052 Heavy, the first officer reported over the radio, and Kennedy Tower responded by instructing them to turn left onto an outbound heading and climb to 2,000 feet, which was the ILS intercept altitude. Hearing this transmission, the captain started to say, "We don't have fuel."
Yes, but I'm not able to access Discord, unfortunately. I do have an email you can send it to, which is basically the only thing I can really access at the moment.
But the first officer again simply read back the clearance and didn't protest any further. The captain continued by saying, "I don't know what happened with the runway. I didn't see it." And he then added, "Tell them we are in an emergency." Over the radio, the first officer now told Kennedy Tower, "We're running out of fuel." But he still didn't use the word emergency. And the tower controller also didn't ask for how much fuel they actually had left. The captain continued to insist, "Advise him we're in an emergency. Did you tell him?" To which the first officer replied, "Yes, sir. I have already advised him," which is the biggest indicator we have that the first officer believed his request for priority had really conveyed their emergency status to air traffic control.
Oh, God.
In fact, though, until the first officer said, "We're running out of fuel," neither the TRACON nor the tower controller knew that Flight 052 had any problem with the fuel at all. As the aircraft continued through its outbound turn, the tower instructed them to contact the TRACON for resequencing, which is not at all what would have happened if the controller believed that they were in an actual emergency, by the way. And once again, the first officer simply complied with that request. Moments later, after the crew advised that they had made a missed approach, the TRACON controller instructed them to climb to 3,000 feet in order to get them back into the approach queue. The captain told the first officer to advise him we don't have fuel, but the first officer only acknowledged the instruction to climb whilst also adding, "We're running out of fuel, sir." Climbing to 3,000 feet would simply waste their fuel and throw away whatever slim chance that they still had, but yet the captain complied and they started climbing anyway.
Oh, God.
The controller now also said, "Avianca 052 Heavy, I'm going to bring you about 15 miles northeast and then turn you back into the approach. Is that fine with you and your fuel?" And before replying, the flight engineer commented that the controller sounded angry, and the first officer therefore meekly replied, "I guess so, thank you very much." And then,
Whoa.
for a while after this, there was only silence in the cockpit. Now, in aviation, we have this concept of 5 hazardous attitudes: anti-authority, impulsivity, invulnerability, macho, and resignation. And that last one, that's the one that I want to talk about here.
Oh, no.
Resignation is that feeling that there's nothing you can do anyway, so why even bother trying? Which is a real problem, because as a pilot, when you're in a nightmare scenario like this one, continuing to try as hard as you can is really the only thing that you can do. Now, I think that these pilots showed signs of resignation even well before the go-around, already when they started accepting instructions that made their fuel situation progressively worse, and actually even in the planning stage. Pilots need to make sure that they stay in control of events, instead of letting events control them, which is what this crew definitely did here. Just going with the flow and allowing things to happen to them. Sure, the captain was likely task saturated and they didn't have any CRM training, but that still doesn't explain why they stayed so relatively passive throughout this. At time 21:32, with the fuel gauges now reading near zero, Flight 052 began its base turn to intercept the localizer for a second approach. Seconds later, the fuel tanks began to run dry, and the engines started shutting down one after another. Amid the sound of engine power rolling back, the flight engineer called out, flame out on engine 4, and then just seconds later, he also added, flame out on engine 3, essential on number 2 and number 1. Knowing that the remaining engines would fail at any second, the captain now desperately called out, show me the runway. But they were still 15 miles away from the airport at this point, out over the north shore of Long Island.
07, we need some more
Over the
70
radio,
chat.
the first officer now pleaded, we just lost 2 engines and we need priority, please. But, of course, it was now way too late.
07
The
chat.
controller gave them a final heading to intercept the localizer, and when the crew acknowledged, that was the last thing anyone heard from Avianca Flight 052. On board, the cockpit voice recorder captured the pilots setting up their instruments for the approach, but then the recording abruptly ended as engine 1 and 2 also ran out of fuel and flamed out, removing the last bit of electrical supply from the aircraft. With no engines or electrical power, the lights also went out as the sound of the engines died away and an eerie quiet fell over the doomed 707. Gliding down through the howling wind and rain, there was nothing that the pilots could do except for hoping that they would come down somewhere flat and open. But unfortunately, they didn't. At time 21:34, Avianca Flight 052 slammed nose first into a wooded hillside in the village of Cove Neck on Long Island, causing the fuselage to break into 3 pieces as the entire plane came to a sharp stop. The nose section was catapulted over a hilltop and through a backyard, while the main fuselage came to rest on a nearly 45-degree slope with its tail lying across a residential road. Inside the cabin, the extreme force of the impact caused the seats to buckle and rip out of the floor, sending passengers crashing into their surroundings with devastating results. Among the 158 passengers and crew, the crash ended up killing 73 people, including all 3 pilots and 5 of the 6 cabin crew. And out of the 85 survivors, all except for 2 infants were seriously hurt with multiple broken bones, severe head injuries, and many other forms of trauma. But because there was no fuel, there also was no fire.
Okay, that was a plus at least.
In its final report, the National Transportation Safety Board determined that the cause of the accident was the failure of the flight crew to exercise adequate fuel management and their failure to convey the emergency situation to air traffic control. Contributing factors included the crew's failure to request updated information on the situation in the New York area, improper traffic flow management by the Central Flow Control Facility, and the high difficulty of the manual raw data approach in bad weather under stress. That prevented the crew from landing the plane on that first attempt. In the years that followed, the crash of Avianca Flight 052 became an important cause for safety improvements around the world, affecting several different areas of aviation. In addition to reforming the way that expect further clearances times are issued, air traffic controllers are now much more strongly encouraged
Oh my god.
to ask flight crew for more information if they suspect that there might be an issue with the fuel. And the International Civil
But what is happening?
Aviation Organization established the first unified global testing standards for airmen's English in order to ensure that pilots from around the world could effectively
Pause, goddammit. Do I actually have to...
communicate in the language of aviation. This crash and also other crashes during that same time period, including the Kegworth air disaster, also led the FAA to implement new standards for
What the fuck is happening right now? Why is my laptop doing this?
airline seat design to ensure that the seats could withstand an impact of up to 16 Gs and stay in position even in the event of severe damage to the.
What the frick is happening? I legit have nothing open. Closed literally fucking everything. And we have this Chrome tab open, OBS of course, and like, I'm even gonna close Task Manager.
Floor. And this accident also endures as a case study for us pilots on how the crew can let themselves fall into a situation from which there is no escape simply by making a series of passive, favorable assumptions about the situation.
Please.
Center Alaska 261, we are in a dive here. But we've lost vertical control of our airplane.
As a pilot, there are a few situations you hope that you will never ever have to experience, and one of them is obviously a total loss of controls of your aircraft, with no checklist available to help you solve it. This is going to be a bone-chilling account of one of the most consequential aviation accidents in modern history, but it's also a story of airmanship and a willingness to keep flying the aircraft no matter what. Stay tuned.
100, 40, 30, 20, 10.
The story of Alaska Airlines Flight 261 took place on the 31st of January 2000, but that's not when this story actually started. No, what happened here had its core deep inside something I call organizational creep, and in order to understand that, we will have to go back many decades, all the way back to the certification of the aircraft involved, and after that we must also take a look at the company operating it. The accident aircraft was a McDonnell Douglas MD-83, which is a variation of the original DC-9 introduced back in 1965. The DC-9 was in production up until 1982 and was then followed by the MD-81, 82, 83, 88 and then finally the Boeing 717. But even though the later types carried many upgrades, the core design and systems could still be traced back to the original DC-9. The part of the aircraft which will become important in this story is the empennage, or the back wing of the aircraft. It consists of the vertical fin, which together with the rudder stabilizes and controls the aircraft around the yaw axis and is therefore referred to as the vertical stabilizer. On top of the vertical stabilizer, the horizontal stabilizer is located. Now, the horizontal stabilizer and elevators control the aircraft around the pitch axis, or in other words, they are the controls who can point the nose of the aircraft either up or down, and this pitch control is done primarily in two different ways. If the pilot wants to get the aircraft to, for example, climb, they can pull the control yoke backwards, which will mechanically activate little control tabs on the back of the aircraft elevators. These control tabs will then move down to force the main elevators up with the help of aerodynamic forces, and that movement will in turn start pitching the aircraft's nose upwards. The elevators provide the primary pitch control, but pulling continuously on the yoke would be very tiresome during long periods of flight. And on top of that, the amount of push or pull needed would also change depending on the configuration of the aircraft, speed, and changes in weight. So there needs to be a way to neutralize those forces somehow. And this is where we come to the use of the movable horizontal stabilizer, which is basically the entire horizontal back wing which the elevators are mounted on. The movable horizontal stabilizer on the MD-80 is about 40 feet wide, and it's, like I mentioned, mounted on top of the vertical stabilizer via two hinges in the aft spar and in the front via a single jack screw assembly, which can raise or lower the angle of the stabilizer's leading edge. By doing that, the aircraft can be trimmed out, so the control forces are alleviated for the pilots, and this is also how the autopilot primarily controls the aircraft in pitch when it's engaged. Now, I will get a bit technical here, but this explanation is absolutely crucial for you to understand what ultimately happened to this aircraft, so stay focused. To control the amount of stabilizer movements, the pilot or the autopilot can do so in a few different ways. On the control yoke, there are two switches, fondly known as pickle switches, who, when they're pressed simultaneously, will activate a primary electrical trim motor, which is mounted with its gearbox assembly connected to the front spar of the horizontal stabilizer. There's also a set of standby switches on the central pedestal who can activate a standby electrical motor mounted on the same location, and this is also the motor that the autopilot is using. Now, in case of an electrical failure of both of these switches, a pair of trim handles next to the throttle quadrant, known as the suitcase handles, can also be used to activate the main motor manually. But what does these motors do then? Well, when any of the two motors are activated, they will start to rotate a torque tube inside of an Acme screw, which run through an Acme nut connected to the vertical stabilizer below. This means that as the Acme screw rotates in either direction, the screw will either lower or raise the angle of the stabilizer in a uniform and smooth way, similar to the way that you lift your car up with a jack screw when you need to change a tire. Now, obviously there are constraints to how much this screw is allowed to move, and that's achieved by programmed maximum and minimum trim values that will stop the electrical motors from running when those values are reached. But if those would fail, there are also mechanical stops at the top and the bottom of the Acme screw who serves as ultimate guarantees that the screw won't move beyond the ultimate maximum and minimum positions. On top of that, there is also a primary trim brake switch in the cockpit, which can be used to stop any trim movement in case the motor will start to run away. Now, those of you with engineering eyes will likely already have noticed that there's only one Acme screw and nut in this system. Shouldn't a system that carries primary control loads of the aircraft be doubled up for redundancy? Well, the way that McDonnell Douglas initially approached the redundancy was to show to the authorities that both the Acme screw itself and the torque tube inside the screw was individually able to maintain the structural integrity of the system. This means that if one of them would break, the other one would still be able to keep the screw assembly together and therefore accomplish the redundancy needed. As far as the Acme nut was concerned, it was shown to be able to operate with up to 90% of the nut threads worn down, and its redundancy was accomplished by inserting more screw threads than needed inside the nut, as well as double spirals of thread. The Acme nut was made out of a slightly softer alloy than the screw, so any wear would naturally happen to the nut first. Initially, the nut was certified to have a service life of 30,000 flight hours, but pretty soon after certification, inspections revealed higher than expected wear on the nut threads. And because of this, inspections were put in place at regular intervals to measure this wear, and when it reached a predetermined value, the assembly was supposed to be replaced. Now, as many of you will know, whenever you have mechanical parts moving up against each other, there will be friction between them.
Yeah, friction will be
the more friction you have, the quicker the wear will be, and because of that, the Acme nut and screw needed to be lubricated at regular intervals using a certified aviation-approved type of grease. And this is where we get to the operator, Alaska Airlines, and the FAA. Initially, after certification of the original DC-9, McDonnell Douglas recommended a lubrication interval of the jack screw assembly every 300 to 350 flight hours. This was then extended for the MD-80 family up to every 900 hours, but in 1996 a revision of the overall maintenance intervals instead included the lubrication in every C check, which happened only every 3,600 hours or 15 months, whichever came first. Now, Alaska Airlines followed these recommendations and extended the interval for lubrication to, in their case, every 8 months, which was actually more conservative than the manufacturer's recommendation. But obviously, that's only if the actual lubrication procedures was done correctly.
Oh no.
When the airline applied to the FAA for this extension, it was immediately approved as it satisfied the manufacturer's guidance at the time. But it would later be found out that the inclusion of the lubrication in the C-check schedule had not actually been approved by or even explained to the original engineers at McDonnell Douglas. It had just been roped in there with several other maintenance checks without evaluation of every individual task. Now, in terms of procedures, according to McDonnell Douglas, the greasing of the nut was supposed to be done by pressing grease into a fitting on the nut until grease came flowing out on top and below the nut. After that, the screw itself needed to be properly greased up before the stabilizer was moved full up and down a few times to properly lubricate all of the involved components. This was supposed to take about 4 hours to do every time, but when the line engineer, who was the last one to deal with the accident aircraft, was asked how he would do that procedure, he said that it would take him about 1 hour to do it, and he couldn't account for each of the individual steps.
That is never good.
On top of this, because of the higher than expected wear to the Acme nut, a procedure for measuring this wear had been designed using a tool that would tension the nut towards the Acme screw and measure how much it would move. This was supposed to be done using specific Boeing-made restraining fixtures to set the correct tension, but Alaska Airlines had decided to instead make their own ones, which both looked and worked slightly differently from the Boeing designs. These wear checks had been recommended to be performed every 30 months or 7,200 hours, whichever came first. But Alaska Airlines had written in their manuals that this check would need to be done every 30 months, but with no hourly limit. This meant that with the busy flying schedule that Alaska Airlines were operating at the time, it would take close to 9,550 hours between each of these checks, and the accident aircraft was coming up towards the end of these 30 months.
B.O.B. real quick, I'm gonna go get something to eat. I'll be right back. We are back!
Can you see how the organizational cheese slices are starting to be crossed? This takes us to the fateful flight on January the 31st, 2000. But before I get into the details, there is this. Is everything you've heard so far making...
No.
In the afternoon of January 31st, 2000, the accident aircraft with the tail number November 963 Alpha Sierra arrived on time to Licenciado Gustavo Diaz International Airport in Puerto Vallarta, Mexico. The inbound crew had enjoyed a completely normal flight with nothing out of the ordinary, and that's also what they reported when they handed the aircraft over to the next crew, who was going to fly the aircraft back to Seattle via a short stop in San Francisco. The new pilot said goodbye to the previous crew and started preparing the aircraft for the return flight. In the new crew, there were 3 Seattle-based flight attendants who were getting things in order for the 83 booked passengers and 2 very senior pilots. In charge was 53-year-old Captain Ted Thompson, who had been working for Jet America and then Alaska Airlines since 1982. Before he had started flying airliners, he had flown for the US Air Force, and at the time of this flight, he'd flown little over 17,750 hours of total time and over 4,000 hours on the MD-80. He was flying together with 57-year-old First Officer Bill Tansky, who also had some previous military experience, in his case from the US Navy. He had accrued 8,140 hours, of which over 8,000 hours was flown on the MD-80, making him very experienced on this type. The aircraft looked like it was in good flying conditions, and there was no problems or history of problems from the last few flights that the captain could see when he was looking through the technical logbook.
Okay, that's good.
First Officer Bill was going to be pilot flying for the first flight with call sign Alaska 261 towards San Francisco, and then Captain Ted would take over and fly the last leg home to Seattle. It was a beautiful day for flying with light winds and good visibility conditions.
Or like visibility.
Once all of the 83 passengers had been boarded, the doors were closed and the engines were started as they were pushing back from the gate. The takeoff trim had been calculated to 7 degrees nose up, which was set without any problems, and at time 13:37 Pacific Standard Time, Alaska Airlines Flight 261 took off normally from Puerto Vallarta and started its climb towards the northwest. First Officer Bill flew the aircraft manually up to around 6,200 feet, where he made sure that the aircraft was then properly trimmed and then engaged the autopilot. After that point, as the aircraft continued to climb towards their planned cruise altitude of 31,000 feet, the autopilot continued to trim normally, using the slower rate of the standby electrical motor, just as it was designed to do. But unbeknownst to the pilot, things had now started to happen in the very back of the aircraft, inside of the acme nut who was holding the jack screw assembly together. For several thousand hours, the screw had been grinding down on the softer nut threads without hardly any grease to lubricate it, and now only a sliver of the original thread was left to guide the screw as the autopilot was turning it. When the aircraft climbed through 23,400 feet, the last stabilizer trim movement was indicated on the flight data recorder, and after that, it froze on a setting of 0.4 degrees nose down. Now, we can't know for sure what caused it to freeze up, but it is possible that the tips of what was left of the acme nut thread now became so weak that they had started to bend under the load of the screw, which just caused the screw to seize up.
Oh shit.
In any case, the way the pilots would have noticed this would have been by seeing that the autopilot was unable to keep speed and climb rate since it just couldn't move the stabilizer. Initially, the aircraft continued to climb at an indicated airspeed of 330 knots, but then it slowly began to level off as it reached around 26,000 feet. As this was happening, the speed started slowing down, and then it restarted its climb again, and the speed dropped further back to 285 knots. Around this point, the trim annunciator warning light would have also illuminated, giving a clear indication to the pilots that something wasn't quite right with the trim system. So, First Officer Bill disconnected the autopilot and took manual control of the aircraft. Now, we have no voice transcripts from this initial part of the flight, since the cockpit voice recorder only gathered the last 30 minutes. But we can assume that First Officer Bill would have immediately noticed that he needed to pull as much as 50 pounds or 22 kilos of force in order for the aircraft to keep climbing. And when he
Holy
tried to
shit.
trim it, the stabilizer trim wasn't working. Like I mentioned in the beginning of the video, the main reason for the stabilizer trim is to remove stick forces from the crew. And since the aircraft was trimmed for a 330 knot climb and the speed now was back at 285 knots, much more back pressure than normal would be needed to keep it climbing. During the next few minutes, the elevators were deflected upwards to continue the climb to 31,000 feet, and after they had leveled off, the amount of back pressure needed was reduced back to about 30 pounds or 13 kilos. That's still a lot, but it's clearly manageable. This back pressure was also then further reduced by a speed increase and a gradual reduction in fuel weight, so that eventually not much back pressure was needed at all to continue to fly in level flight. As this was going on, the crew would have also run through the stabilizer inoperative non-normal checklist in their quick reference handbook. And that checklist would have told them to try utilizing the two standby systems in order to clear the problem and get the aircraft back in trim. If that failed, the checklist instructed the crew not to re-engage the autopilot, because the fact that the trim wasn't moving with any of the motors indicated that something else was causing the jam, and it would therefore be inadvisable to keep trying to activate the motors, which the autopilot would definitely do.
Yep.
In spite of this, after the aircraft had been flown manually for nearly 2 hours along the route, the autopilot was re-engaged at time 15:47. The reduction of the aircraft's weight combined with the higher airspeed would have made the stick forces needed small enough to enable the autopilot to be re-engaged, and it is possible that the crew just wanted the extra capacity to continue to troubleshoot the problem. Now, you might be wondering why the pilots didn't just turn around and divert back to their departure airport as soon as they noticed the problem that they were having. Well, with the information that they had at that time, a straight return would have led to an overweight landing with higher than normal approach and landing speeds. And from a strict handling perspective, the problem that they thought
Well, at least they would have survived.
what they had wasn't that bad, and the non-normal checklist didn't advise them to land at the nearest available airport. But that doesn't mean that the pilots didn't think about diverting. Actually, this was the very thing they were discussing when the CVR transcript eventually started at time 15:49 and 49 seconds. The pilots were then still troubleshooting the jammed stabilizer, and the captain was in contact with the Alaska Airlines maintenance and operations frequency. The engineers had been going through the maintenance history and hadn't been able to find anything, especially anything relating to the stabilizer. In any case, Captain Ted advised maintenance and operations that they wanted to divert to Los Angeles International Airport, LAX, instead of continuing towards San Francisco. And when operations heard this, they were clearly annoyed by this fact and wanted him to clarify.
I understand you're requesting a diversion to LA for this discrepancy. Is there a specific reason you prefer LA over San Francisco?
Clarify why they couldn't just continue towards San Francisco instead. Now, this is the kind of thing that just makes my blood boil. A pilot never requests a diversion unless he or she deems it absolutely necessary. A diversion will always prolong the working day, and it creates inconvenience for the passengers, the crew and the company, so a diversion is not something that a pilot would just ask for without proper cause. This seems to also have been the
Well, a lot of times it's windy and rainy and wet in San Francisco, and it seemed to me that a dry runway where the wind is usually right down the runway seemed a bit more reasonable.
opinion of Captain Ted, who explained to Alaska Operations that he simply didn't want to fly past any suitable airport with this type of problem, and that the winds and conditions in LAX normally were more suitable for landings with issues like this. The operations controller said that he should, of course,
Well, we want to do it safe, so if that's what you feel is safe, we just want to make sure that you have all the info.
do what he thought was safest, but he also informed the captain that this
Okay, the other thing you gotta know is that they're talking about holding and delays in San Francisco from the maintenance facility. Planning
might
LA
cause
seemed like a smart move from Airways move.
delays for the flight back to San Francisco
What?
later on,
Uh-huh.
as well as issues with getting landing clearance for an unscheduled international flight into LAX. All of this just sounds like further ways to try and pressure the crew to continue to their original destination, which wasn't lost on the captain, who
I really don't want to hear about the flow being the reason you're calling us, because I'm concerned about overflying suitable airports.
Complained about it to his co-pilot. One more thing that is important to remember here is that the
I think for the subscription, Natila, we appreciate it.
flight was still well under control at this point, and no urgency or emergency call had been made. This meant that the flight was treated just like any other aircraft in the airspace, and that might also be an explanation to the relaxed attitude of the Alaska Airlines operations controller. The pilots decided to continue following their route until they got closer to Los Angeles and then divert. This way, they could burn a little bit more fuel to reduce the landing weight and speeds, and it would also allow them more time to continue troubleshooting and make a plan
Yeah, we kind of assumed that we had what's the wind again there in San
for
Francisco.
their arrival. From the conversations the crew was having, you can clearly hear that these were
1806, so that's the runway 16. What we need is runway 19, and they're not landing runway 19. I don't think so.
two very experienced and well-trained pilots who were capable of thinking outside of the box. They were even asking on the operations frequency
You might just ask them if the ground school instructor they're available and discuss with them, or a simulator instructor.
if there was any instructor pilots available, as they might be able to think of something that the pilots had missed.
Yeah. Even though I'm pretty sure, like, he's not the very experienced pilot crew, right? Even though they are very experienced, that doesn't mean they're not allowed to ask for, like, ground school instructors, because maybe, even though they have a lot of experience, there could always be something that they don't actually know. And getting help from a ground school instructor could, like, making, like, something that they don't know yet. Like, something they just, like, don't know. But the instructor do know, which is actually kind of, yeah, good idea.
This is a very good idea, but sadly there weren't any instructors available. Captain Ted also advised operations that he intended to descend the aircraft down to a lower altitude and start configuring.
Okay, here's my plan is we're gonna continue as if going to San Francisco to get all the data, and then begin our descent back into LAX. And at a low altitude, we'll configure and check the handling envelope before we proceed with the approach.
The aircraft to see how it behaved. Doing this is an excellent idea when you're dealing with flight control problems, as it's much better to find out about.
Yo, what is Frosty yapping about now? In the shadowy corner of the clone place which is chat, a wild Carvana appeared, elusive and whisper in the night slipped with his fingers and vanished. Hours rolled in like foggy dawn, but the loyal crew knew to hydrate and stretch. And the break ended, another chance with a mask arose, only to escape into the other. The chat's cries of rigged echoed into the digital abyss. Oh my god.
Potential additional control problems at a higher altitude, when there is more time to rectify them and then make a new plan for the landing. At time 15:59 and 44 seconds, the captain handed over the controls to the aircraft, which was still being flown by autopilot at this point, to First Officer Bill. He then changed the frequency over to listen to the automatic terminal information service at LAX, where the weather was good with winds almost straight down the runway, good visibility and only some few clouds around. Once that was done, he continued talking to the LAX.
I know you're busy on this, but we're discussing it up here. Can you just give us the wind at San Francisco? Just put them up on the screen.
Operations about getting the landing performance figures calculated for them, as well as an
San Francisco. Okay, we've got a wind or 178
update on the winds in San Francisco to make sure that the weather was indeed better in LAX. These were all standard diversion preparations, and everything was still under control at this point. But that was soon about to change.
Oh no.
At time 16:07 and 51 seconds, a new engineer's voice called up Flight 261 on the operations frequency. He said that he just wanted to know if they still had the same issue with the stabilizer, and if they had indeed tried all of the different options, including the pickle switches on the control wheel and the suitcase handles.
Yeah, we tried everything together.
The captain responded that they had indeed tried everything, even together, and that they
would won just about everything. If you got any hidden circuit breakers, we'd love to know about them.
Love to hear if he had any other suggestions, like hidden circuit breakers or something. The engineer responded,
I'm off I'll look at the circuit breaker. Guy just as a double check, and yeah, I just wanted to know if you tried to pick a switch in the suitcase handle to see if it was moving, and Jesus Christ, it's late, and that scared the shit out of me. Thank you for the subscription, Natila Delima. Oh, other switches other than the suitcase handles alone or nothing.
That he was double checking the CB guide, but he just wanted to check that they had really tried everything. Captain Ted said that they definitely had, and that the AC meter, which is an instrument that shows the alternating current load, showed a big increase in electrical load when they were using the normal trim switches. Now,
I would
this is
play drum
important
kits, but it's
information
like
because
I'm
it clearly shows that the motor
I don't actually have my
itself was
drums
working,
snare
but
with
that
me.
it wasn't successful in actually moving the screw. That's a sign of potentially serious damage to the whole jack screw assembly, but that would have been really hard for the pilots to figure out from the little information that they had at that point. In later versions of the Quick Reference Handbook checklist, the crew would be clearly told not to retry operations of any trim systems if they
Yeah, but they didn't have that version.
didn't
Unfortunately,
work after they were tried the first time, and we will very soon see the reason for that. Now, because of the repeated questions from the engineer, the captain now seemed to have come up with an idea. Because at times 16:08 and 59 seconds, he said to the first officer, "I'm gonna click it off. You got it?" And
at this moment, he knew he fucked up.
First Officer Bill responded, "Okay." 10 seconds later, the captain continued by saying, let's do that. And this will click it off, followed by the autopilot being disconnected. In all likelihood, what the captain did here was to push both the pickle switches and possibly also the standby handles at the same time, which disconnected the autopilot. Now,
At this moment, he knew.
It was at this moment that he knew. He fucked up.
Yep.
a loud clunk could be heard on the cockpit voice recorder, followed by two faint thumps from the back of the aircraft. The next sound was the audible stabilizer movement tone, followed by First Officer Bill exclaiming,
"Holy shit!"
The horizontal stabilizer now moved from its position of 0.4 degrees nose down, which it had been jammed in for the last 2 hours, to slightly beyond its maximum nose down position of 3.1 degrees. It's
Okay, and I know it's kind of like irrelevant. Okay. As a person with OCD, why 3.1 degree? Make it 3 degrees!
possible that the sudden engagement
Okay, I know
of
it's
the
not really
trim
relevant,
motor
but
started
still.
moving
OCD.
the screw again, causing the remaining threads inside the acme nut to
Acme threads have just left the chat.
finally shear completely off, allowing the screw and the stabilizer to start moving freely inside of the nut. The fact that the elevators were pulled upwards to try and counteract the dive just caused tension on the screw, which moved it even further up, making the situation even worse. Now, the reason we can assume that this is what happened was because the movement of the trim during the seconds after the two thumps were heard was not linear, as it would have been if the screw was just rotating normally along the threads. The upwards movement of the screw only stopped when the mechanical stop slammed into the bottom of the acme nut, leaving clear indents and scrape marks on it.
Oh, damn.
The sudden stabilizer movement now caused the nose of the aircraft to pitch forward, leading into a rapid dive, and with that, a big increase in speed. The first officer shouted out, "What are you doing?" And the captain responded, "I clicked it off," likely referring to the autopilot. There was no way for the pilots to know what had just happened in the back of their aircraft, but this call from the captain actually illustrates a very important point.
You're gonna die from falling into the lava. Because the screw BS crew.
One of the main reasons we're not
Well, we lost Ethan Moderator. Time to prepare the grave and coffin. This is what's gonna happen to Tim. Dr. O, just a headache, you'll be fine, Google. Misha just had to organize a funeral. Google normal tips. Internet, keep calm, everything will come back to normal. Off the internet. Doctor, your visitors. Kim, who are they? The visitors. Oh, I love YouTube comments. 2019, why do you hear boss music? 2020, why do I hear funeral music? They really took the play this at my funeral too seriously. If my funeral doesn't look like this, I'm not coming. Bro, we're just gonna deny dying. Anyways,
forced to
back with
engage the
this.
autopilot when we have flight control problems is because the autopilot can actually mask the control issues and cause a very sudden pitch or roll if it suddenly disconnects. In this case, the pilots now spent the next 80 terrifying seconds trying to pull the aircraft out of the dive. The captain called air traffic control telling them that they were in a dive, and as he was doing so, a strong vibration could be felt throughout the aircraft. The captain called out, "You're stalled," which was not the case, but the vibrations together with the quick descent rate could possibly be interpreted as that. This would also explain why he, a few seconds later, called out, No, you got to release it, possibly referring to the way the first officer was pulling back on the controls. There were several forth and back calls between the pilots until finally the overspeed warning started sounding. This caused the pilots to extend the speed brake, and that seemed to improve the situation slightly, but it still took a combined effort of around 130 pounds or almost 60 kilos of force to pull the aircraft out of the 6,000 feet per minute dive. The crew finally managed to get the aircraft more or less under control as they reached about 24,000 feet. They then asked air traffic control for a block altitude between 20 and 20.
Yeah, block would basically mean like block altitude is basically where like if you regular hello there aviation and sirens of TN. I'm just gonna call you TN because that is a mouthful to say every single time. Usually, so like when you get cleared for regular altitude, it's like needs 25,000 feet as an example. If let's say you cleared 25,000 feet, that means you have to stay at 25,000 feet, so like in like buffer like few feet or so, because obviously you can't keep that like exact altitude all the time. But block altitude is like where like you like free to go between two altitudes you get. So let's say about 20,000, 25,000 feet. You're allowed to have like a 5,000 feet margin.
25,000 feet, which would allow them clearance to other aircraft in case of another dive, and then they started discussing what had just happened. They both agreed to stay away from whatever switch they had touched that had initiated the dive, and they also agreed that the situation was now significantly worse, with the stabilizer in a full nose-down position. They also started talking about how they needed to slow the aircraft down and get the slats and the flaps out to see if they could still control it, but before they could do that, Captain Ted went off the radio to again talk to maintenance and update them on their now
Wait, you in the shower right now, bro?
Much worse new situation. When they answered, the engineers didn't have much
We did both paper sweats and the ticket sandals, and it ran away full nose trim down.
advice to bring them. They just said that it was up to him if he wanted to again try the trim system. This advice sparked a conversation between the two pilots about whether or not they should maybe try it again.
No.
But here, the first
Don't.
officer spoke up clearly.
I mean, I've talked to my boyfriend Cass in the shower before. Don't ask why. That's another story for another time. But yeah, how are you even doing that?
And he said that he didn't think that that would be a good thing to do. First Officer Bill also, at this point, reminded the captain that he needed to make a PA to the now likely terrified passengers in the back. Captain Ted agreed, and he made a short, concise PA without giving too much detail, but also
folks, we have had a flight control problem up here. We're working on it. That's Los Angeles off to the right there. That's where I intend to go. We're pretty busy up here working on this situation. I don't anticipate any big problems. That might change. We don't anticipate any big problems once we get a couple of subsystems on the line. But we will be going to LAX, and I anticipate us parking there in about 20 or 30 minutes. Oh yeah, my friend Cat, my boyfriend Cass, had like a little phone stand they have in the shower, as well.
Also without any type of bullshit. A very well-made PA given the extreme circumstances that they were in, and hopefully that gave some reassurance to the passengers. The Los Angeles air traffic controller now handed over flight 261 to the approach controller, and when the captain called him up explaining the nature of their problems, they were cleared to proceed direct towards Los Angeles. But here, the captain made...
What did I say?
They were
That's the 261. LA Center, Roger. You cleared Los Angeles Airport by your present position. Direct Santa Monica, direct Los Angeles. And you want lower now, or what you want to do, sir?
cleared to proceed direct towards Los Angeles.
The Nokia brick phone.
But here, the captain made a truly heroic decision. He likely knew that his jet was in a very bad shape, so he declined the direct and instead asked to remain on radar vectors out over the bay in order to complete the configuration.
Center, Alaska 261. I need to get down about 10 minute configuration, make sure I control my jet, and I'd like to do that over here, out here over the bay if I may. Untouched wiring. No, might be watching a Samsung fridge.
Tests over water rather than over populated land. By doing so, he would avoid third-party damage if something went further wrong, and it shows extraordinary situational awareness under pressure. Once this decision was taken, the captain asked for a further descent clearance down to 10,000 feet in order to complete the handling tests. ATC initially told them to stand by, and now again the first officer spoke up and suggested that they should run the tests at their present altitude rather than descending down to 10,000 feet and do them there. Now, I understand the captain's idea of doing it at a slightly lower altitude where the air is thicker and more similar to what they would face on approach, but the first officer's suggestion to try it with more altitude margins also makes perfect sense. It's great to see airmanship and CRM play out under such dire conditions. Air traffic control cleared the aircraft to descend to 17,000 feet initially, which the crew read back, and they also reminded the controller that they needed a block altitude. They were cleared to turn on to heading at 280 degrees out of the sea and then change controller frequency over to the next sector. The purser was now called into the cockpit, and when she came in, she informed the pilots that the crew had heard a large bang in the back of the aircraft just prior to the first dive. The captain thanked her for the information, and he told her to secure the cabin and strap everyone down because he was planning to unload the aircraft and see if he could get the trim working that way. Unloading the aircraft would mean pitching forward to reduce the back pressure and therefore the load on the stabilizer. This type of maneuver has been known to be effective in fixing certain types of stabilizer jams in other aircraft types, like the 737 for example, where this was referred to as the roller coaster maneuver. However, trying that would again mean also trying to activate the trim system. Anyway, the first thing they needed to do was to try and configure the aircraft and see if it was actually controllable. They started with retracting the speed brake, and then at times 16, 17 and 54 seconds, Captain Ted took control of the aircraft and asked for the slats to be extended. First Officer Bill moved the slat handle to the extend position, and this apparently made the pitch down tendency even worse. The captain then asked for the flaps to be extended to 11 degrees, and when the flaps started to move, the aircraft actually stabilized and became slightly easier to fly again. Now, for some unknown reason, once the test was complete, the captain decided to retract the flaps and slats again, even though the aircraft was flying reasonably well in that configuration. He possibly did this because he had just wanted to try the configuration for the landing later on, but wasn't planning to actually keep it all the way to LAX. So here comes another lesson for you budding pilots out there. If you ever have flight control problems like this and fuel is not an issue, don't change the configuration back after you have started configuring it.
Yeah.
It's generally better to just continue to fly the aircraft in this new configuration than trying to test your luck by reconfiguring more times. Anyway, the next thing that the captain wanted to do was to try to unload the stabilizer and see if that
Yeah, what I'm gonna do is get the nose up, then let loose, then let the nose fall, and see if we can stab it when it's
would
unloaded.
sort the trim problem out. But here, First Officer Bill put his foot down. He said that he didn't
You mean
think
use this again? I don't think we should. If it can fly, it's like, I think it's in control if we
it was a
always
good
try and
idea
land
to
it.
touch it again since the aircraft was flying. And he also said, I think that if it's controllable, we ought to just try and land it. Captain Ted listened to him and agreed, again showing excellent CRM between the two, but unfortunately, this was just not supposed to be. Because only 5 seconds later, a series of faint thumps could be heard from the back, followed by the first officer saying, "You feel that?" The captain, who had the controls, responded, "Yeah, okay, give me... This is a bitch," indicating that he now required much more forces to keep the aircraft from pitching down. What had likely happened at this point was that the torque tube inside of the Acme screw had been subjected to significant bending and pulling loads during the 10 minutes that had passed since the shearing of the Acme nut threads. Those bending loads had activated existing fatigue cracks inside of the torque tube, and now those cracks caused the torque tube to completely fracture into two pieces and therefore leave the nut and the backstop completely.
Oh
This
shit.
meant that the
FAA issues flight advisories from Mexico South. Oh god. Oh no.
stabilizer was now allowed to move almost freely around its aft hinges. It now slammed up against the vertical stabilizer tip fairing brackets, who now became the only thing holding it from moving even further upwards. This caused the stabilizer angle to move from 3.1 degrees to 3.6 degrees nose down, which explained the additional pitch down that the captain was feeling. The captain almost immediately asked for the slats and flaps to be redeployed, as the aircraft had been easier to control with those extended, but this was sadly too late.
Oh, 7
The vertical
chat.
stabilizer tip fairing brackets were not made to hold the type of loads that the stabilizer was now exerting on it. At time 16, 19 and 35 seconds, a horrible noise was recorded on the cockpit voice recorder, and simultaneously several small radar returns could be seen on the air traffic control radar as the tip fairing was ripped off and separated from the aircraft. The stabilizer now moved upwards to an angle too high to measure on the flight data recorder, and this caused an immediate and violent pitch forward. This was a hopeless situation to recover from, as the whole horizontal stabilizer was now completely out of control, but that didn't stop Captain Ted from trying. What he now did was to, instead
Lock
of trying
in,
to
chat.
pull out of the 70 degrees deep dive, he pushed forward and rolled the aircraft left over to an inverted position, effectively counteracting the downward pitch of the stabilizer. He called out, "Push, push, push and roll," whilst the first officer called out, "Mayday," but without actually transmitting it on the radio. Because of the roll, the pitch decreased from minus 70 degrees to 29 and then minus 9 degrees, as they were now flying inverted out over the bay. At time 16, 19 and 54 seconds, Captain Ted called out, "Okay, we're inverted, and now we need to get it," indicated that he wanted to get it rolled back into a normal position again. And as he was trying this, they were passing 16,400 feet, still descending with a speed of 208 knots. During the next few seconds, the flight data recorder indicated aileron movements both in left and right direction as the flaps were being retracted. Captain Ted called out, "Push, push, push the blue side up," indicating that he wanted to get the aircraft back on the right keel again, and that was followed by a call to kick rudder, kick left rudder, left rudder. First Officer Bill responded that he couldn't reach it, and Captain Ted then called, "Okay, right rudder, right rudder." This effort didn't work, and 10 seconds later, Captain Ted said, "Gotta get it over again, but at least upside down we're flying." But sadly, this call was almost immediately followed by the sound of several compressor stalls and the sound of the right engine spooling down, likely because of the extreme angle of the oncoming air that was hitting the engine inlets. From this point, there was nothing more that could be done. Captain Ted asked for the speed brakes to be extended, but his last words could be heard on the cockpit voice recorder at times 16:20 and 56 seconds when he said, here we go. Less than a second later, the aircraft impacted the Pacific Ocean and all 88 people on board were instantly lost.
Rest in peace.
Several other aircraft in the area had witnessed Flight 261's final descent, and with the help of them and radar pictures, the crash site was quickly found.
That's good.
The debris was scattered over the sea floor, and it took a week to salvage the majority of the pieces, and among them was the flight data recorder, the cockpit voice recorder, and most of the jack screw assembly from the horizontal stabilizer. With the help of those pieces, the NTSB investigators could relatively quickly start honing in on what had caused this horrible tragedy. When they looked closer on the Acme screw and knot, they saw that the knot was almost completely smooth with only remnants of thread still left inside. On the Acme screw, they found several spiral-formed pieces of thread which had been ripped out of the knot, likely during that first dive. But what really shocked everyone was that there didn't seem to be any grease at all left, neither on the screw or on the knot. The grease fitting on the knot was clogged with a grey mixture of old grease and wear material, and the rest of the components were completely dry. There was no lubricant at all on them. This led the investigators to start scrutinizing the maintenance records of Alaska Airlines, as well as interviewing mechanics and engineers. Big discrepancies were quickly found in both their maintenance manual and how the maintenance work was actually being carried out at their various technical centers. On top of that, important management functions were not filled in the airline, which had caused real confusion about who was responsible for what. This had happened over several years as the Alaska Airlines operation kept growing, and this is
That's my joke. That's my joke. Stop doing my joke.
Creep. It had all happened in small incremental steps. The conclusion of the investigation was that the crash had been caused by a loss of control due to the in-flight failure of the horizontal stabilizer trim jack screw assembly. Contributing to the cause was Alaska Airlines' extended lubrication schedule and wear checks, which had both been approved by the FAA. Those two components, combined with one or possibly several poorly executed lubrications, meant that excessive wear went undetected and ultimately led to the complete failure of the threads inside of the Acme knot and the subsequent failure of the torque tube. There were 24 safety recommendations that came out of the investigation. A few of them gave clearer guidance to pilots about not repeating actions in checklists regarding the trim system and not using the autopilot with flight control problems. But the vast majority of the recommendations were aimed at Alaska Airlines and the FAA regarding maintenance intervals, lubrication and wear checks of the horizontal stabilizer. After the accident, the lubrication schedule was immediately changed to be completed every 650 hours on all MD-80 aircraft. There were also recommendations about not allowing certification of aircraft unless they could prove that they
For the implementation of any proposed changes in allowable lubrication of applications for critical aircraft systems, require operators to supply to the FAA technical data, including performance information and test results, demonstrating that the proposed changes will not present any potential hazards, and obtain approval of the proposed changes from the principal maintenance inspector in concurrence from the FAA applicable aircraft certification office, Alpha-01-45.
weren't susceptible to catastrophic single-point failures
That was a lot to read.
happened in this case. The two pilots, Captain Ted Thompson and First Officer Bill Tansky, were posthumously awarded the Airline Pilots Association Gold Medal for Heroism in recognition for their actions during the emergency.
W pilots.
And if you think that you recognize some of the scenes from this video, that's likely because the same failure and similar pilot actions were used in the 2012 movie Flight, starring Denzel Washington.
Next one.
A Boeing 767 is climbing out over the dense jungles of northern Thailand. The pilots are settling into their seats for the long flight ahead when suddenly
Actually, I think we can skip this one, actually, not gonna lie. This one is actually kind of good.
Most people who are afraid of flying hate seeing news about aviation accidents and incidents. But now imagine that you're seeing live coverage on an ongoing incident as it's happening, but you are sitting inside of the aircraft it's happening to. That's exactly what happened to the passengers on board JetBlue Flight 292, and I will tell you the entire story, so stay tuned.
I'm gonna get another food. Give me a second, chat.
A huge thank you to Blinkist for sponsoring this video. The story about Jet2 Flight 292 started on the 21st of September 2005, and the aircraft involved was a 3-year-old Airbus A320. The aircraft started its stay in JFK Airport in New York, and before the first flight, the engineers had done some light maintenance work to the nose gear, where they had replaced some proximity sensors. These are basically sensors that feels if the aircraft is in the air or on the ground. Once the maintenance job was complete, the aircraft was flown over from JFK over towards Bob Hope Airport in Burbank on the west coast of the United States. And there it was supposed to do a quick crew change, and the aircraft was then supposed to fly back towards JFK later in the afternoon. For the return flight, there was 140 passengers scheduled, 4 cabin crew members and 2 pilots. Now, the 2 pilots were both very experienced. The captain was a 47-year-old with 10,800 hours and about 2,500 hours on the Airbus A320. He was assisted by a 37-year-old first officer who had around 5,700 hours and just under 1,300 hours on type. The weather in Burbank was beautiful, with only some high clouds, good visibility, light winds, and it was decided that the first officer was going to be pilot flying for the return flight to New York. So he started setting up the cockpit, started programming the flight management computer, while the captain did the walk around outside. Now, during the walk around, the captain didn't notice anything suspicious, so he got back into the cockpit, and together the crew finished up the pre-flight preparation, the checklist, and started preparing for the pushback. Before they could go, though, they had to complete the fueling, and they had requested quite a lot of fuel, 14,750 kilos for their flight over to New York. But eventually the fueling was completed, the crew received the fuel receipt, and at the time 15:17 local time, the Airbus A320 started pushing back from the gate and started taxiing out for takeoff runway 15 in Burbank. The first officer was pilot flying, initiated the takeoff roll, he set takeoff thrust, the aircraft started accelerating down the runway, it got airborne, and once it achieved positive radar climb, the first officer asked the captain to select gear up. Now here is where the problems are starting, because the captain reaches over and, according to his statement, tries to move the landing gear lever up, but it won't move up. Instead, he receives the first ECAM message, which is landing gear shock absorber fault, and then very quickly followed by nose wheel steering fault.
Oh shit.
Now, what has actually happened here is that 2 lugs on the upper support of the nose wheel shock absorber has completely sheared off, probably on an earlier flight. Now, the function of those 2 lugs is to keep the shock absorber from being able to rotate inside of the nose gear leg. And without those lugs, the nose gear has actually moved slightly out of position after takeoff. This was then felt by the landing gear control and interface unit, the LGICU, which stops the retraction of the landing gear. And the reason it's doing that is because there's just unlimited amount of room inside of the nose wheel well bay. And if the nose wheel is not in the correct position, then it might not have enough room to be
yes, slightly twisted.
Retracted properly. So that's the reason for the first warning that was issued. And on top of that, another computer called the Braking and Steering Control Unit, the BSCU, has also noticed that something is off with the nose wheel, and it has deactivated the nose gear steering, and that was the reason for the second ECAM warning. Now, it was later found that it was actually the BSCU that was part of the reason that this problem happened in the first place.
But what?
Because the BSCU had on previous flights been doing something called a self-test, which has happened anytime that the gear was selected down, the BSCU would start to move the nose wheel left and right a couple of times in order to just check that the nose wheel steering was working properly. The problem was that it was doing this as many as 57 times during the descent in towards the airport.
Damn.
And because on this aircraft the shock absorber had not been properly pressurized, it hadn't been serviced properly, this caused a bit of friction to build up in the upper support. And when the BSCU was doing all of these self-tests, it caused fatigue cracking in those lugs, which eventually broke them off. The pilots, of course, had no idea that this was going on. They only knew that they were facing a potentially very serious problem with their landing gear. So the captain got into contact with SoCal Control. SoCal gave them a clearance to climb to 14,000 feet and then handed them over to Los Angeles Control. Los Angeles Control then gave them vectors in like a box-like holding pattern over the Palmsdale-Lancaster area at 14,000 feet. Now this problem didn't only stop them from retracting the gear, it also stopped them from engaging the autopilot and the autothrottle, which meant that the first officer was now hand-flying the aircraft with gear down at 14,000 feet, and he was also taking care of the radio communication, because as they were now holding, the captain started to get into contact with JetBlue management, both the dispatch and their technical department. JetBlue Maintenance did a remote diagnostic of the aircraft, and that diagnostic showed that there was a possibility that this might be an indicator fault. But together with the flight crew, they decided that the best thing to do is probably to fly over towards Long Beach Airport. In Long Beach, JetBlue has a major maintenance hub, and potentially come in and do a landing there to have a look at it. After they had decided to do this, the captain got into contact with the cabin crew and informed them about what was going on and about their plans to go over towards Long Beach. And it's at this point that the cabin crew informs him that the passengers are actually able to follow their own flight on the in-flight entertainment system, because the aircraft has an uplink that enables the passengers to watch TV. And of course, this has now been going on for a while, and because this is happening over the Los Angeles area, multiple TV stations have picked up that this aircraft is having a problem. So the passengers are actually watching themselves on news in real time, which is not something that...
Wait. I'm gonna read this. In shady corners, in place Richard chat, a tale unfolds. Ads roll like fog over cityscape, but loyal viewers know to stretch and hydrate. The call to clip moments echoes through the alleys. Post your finds, they say. Meanwhile, aviation advisories drop like secret memos, and while Nordina escapes capture amidst the laughter and cries of rigged. The stream continues speaking in the night. Damn.
I've ever heard of before this, and it's definitely not something that I would like to be part of myself. The aircraft now starts to descend in towards Long Beach, and the pilots have informed air traffic control that if they are able to do a successful landing, they won't be able to taxi off the runway because they're having this problem with the nose wheel steering. During the descent in towards Long Beach, the captain also asked the tower if it would be possible to do a low altitude flyby of the tower so that they can inspect the position of the nose gear prior to their actual landing. This is agreed to by air traffic control, and as the aircraft is entering the approach in towards Long Beach, a local traffic watch helicopter which is nearby is able to see them on approach and can tell them that yes, the nose gear is actually angled 90 degrees towards the direction of the aircraft. The pilots acknowledge this, but they continue the low approach and flyby of the tower anyway. And as they're doing the go-around, the air traffic controllers in the tower can indeed verify that the nose gear seems to be twisted 90 degrees off its axis. The pilots now know that they're facing a much more serious problem than they initially thought. The captain issues a mayday call at this point, and then they request a climb to 6,000 feet to keep troubleshooting the issue. When they level off at 6,000 feet, they know that there are no ECAM actions for this particular problem, and there's no real guidance in their manuals either. However, there is guidance for something called landing with an unsafe landing gear. Now, this is not exactly the same as the pilots are experiencing, because they actually have all of the landing gear extended and they have green indication on their landing gear indicator, basically telling them that the landing gear is safe. But they also know that the nose wheel is 90 degrees towards the axis, and they're not sure that if they land with this problem, the landing gear will be able to take that amount of stress that it will be subjected to. It could potentially collapse, and in that case, they are theoretically in a situation with an unsafe landing gear. So that is how they're approaching this issue.
Yeah.
Now, one thing that is playing in the pilot's favor here is the amount of fuel that they have on board. The Airbus A320 is a short to medium haul aircraft, which means that it has a reasonably small difference between the maximum takeoff weight and the maximum landing weight. And because of this, there's not really a need for a fuel dumping mechanism on an Airbus, just like it's not on the aircraft that I fly, the Boeing 737. This means that the only way for this aircraft to reduce its landing weight, and by that also reducing the potential stress on their nose gear, is to burn off fuel. And they have a lot of fuel on board. So this is what they're now starting to do. The aircraft is now once again receiving vectors, and this time they are in the area between Santa Catalina Island and Long Beach Harbor. And once again, the pilots have to discuss together with the company representatives what the best solution to this problem is. And the kind of things that they're talking about is, for example, is there any system reset that we can do that could potentially get the nose gear back into the centered position again? Also, what kind of fuel will give us the best aft center of gravity that will take away as much as possible the stress on the nose gear after landing? What kind of configuration should we be using during the landing, and how is the aircraft going to handle once we lower the nose gear? Are there any other checklists that we should be going through that is not immediately apparent to us?
I like this thinking, like it a lot.
And also, how should we deal with the passengers? How should we brief them and the cabin crew, and what would we do after landing? What will a potential evacuation look like? Now, all of these kind of discussions and the way that this flight crew is discussing amongst themselves shows a fantastic use of threat and error management. Because this is exactly how we're supposed to deal with it. You are faced with some kind of problem, and then you have to kind of project how this problem is going to affect you in the future. That is the management part of threat and error management, and this is exactly what they're doing. This is actually a very good example of how time available decision making is supposed to look. Another thing that the pilot needs to decide at this point is where they are going to divert to. Initially, they were looking at Edwards Air Force Base, Miramar, but the captain decided that he would actually prefer to go to Los Angeles International Airport. And the reason for that is because the runway is slightly longer and they have a very wide runway as well. And he thought that if we are going to have problems with the directional control of the landing, it is better to have a wider runway. Once again, showing good situational awareness.
Yeah.
In the back of the aircraft, the cabin crew has...
The crew is doing a very good job, not gonna lie. W crew.
Been briefed by the pilots about the problem they're facing. They have also been told to move passengers and hand luggage from the front of the aircraft towards the back in order to try to move the center of gravity a little bit more backward to once again get pressure off the nose wheel. They're also handing out blankets, pillows. They're explaining what's going on to the passengers. They're serving them with non-alcoholic drinks. And they're starting to prepare.
See, I like crews like this. They care for the passengers, like in situations such as this. W flight crew. Amazing. Even though they're kind of in like a dire situation like this, they still take care of the passengers. Make sure they're not freaking out too much, that they're safe, they're calm. They're able to like process demand and like commands well. Like if like the cabin crew needs to quickly need to tell them to do something, that like they're able to do it. Amazing flight crew. Good example for how a flight crew should work and look like.
Prepare them for an emergency landing. And I have to say that the description of this in
flight crew immediately reference the flight attendant manuals and ways for information from the flight deck.
The final report shows excellent competency from the cabin crew. They're doing the job exactly the way that they're supposed to do. Really, really nice to see. Unfortunately, the passengers were still able to watch themselves on the news on their in-flight entertainment screens at this point. And one of those passengers, screenwriter Zach Dean, actually started to really contemplate his own mortality in this situation. And that eventually led up to him writing a script that became the movie Deadfall. Now, the cabin crew did eventually switch off the in-flight entertainment screens about 50 minutes prior to the approach into Los Angeles Airport. And what happened during that approach and the subsequent landing, I'm going to tell you all about after this short message.
No.
Check it out now. Before they start the approach, the captain once again calls up the cabin crew and he informs them that there is a possibility that after landing the nose gear might collapse. And if it does so, there's going to be an evacuation needed. But of course, with the nose gear collapsed, the aircraft is going to be at a very strange angle, with the nose very low and the back of the aircraft very high. So he tells them to not use the aft emergency exits if this happens, because it's a chance that the exit slides are not going to be long enough to actually even touch the ground below them. Once again, this shows exceptional threat and error management and situational awareness on behalf of the flight crew.
See, this looks like what we want.
And start descending down towards Los Angeles airport. Millions of people are watching this happening live. This means that there is a big possibility that the relatives and the friends of the people on board are also watching this. The cabin crew knows this and they kind of step up away from the procedures for a short second, where they let all of the people on board take up their mobile phones and call their friends and families for a couple of minutes before they tell them to once again switch it off.
Again, see, this is a good flight crew. They actually care for the passengers, like I said earlier. They're like, even though you're not, even though you should have your phone in the airplane mode, while of course on airplane, they're letting them take them off airplane mode, just like to let the friends and family know that they're okay. Just say, because like the flight crew are humans too. So yeah, amazing. Again, amazing flight crew. Really appreciate them
for landing, and I think that this just shows great compassion and understanding on behalf of the cabin crew. On the ground, the rescue personnel at Los Angeles Airport have had plenty of time to prepare for the arrival of the aircraft. They have gathered all of the emergency equipment that might be needed close to runway 25 left, where the aircraft is going to eventually land, but they didn't spray any fire retardant foam on the runway. And the reason for this, I've actually talked a little bit about in a previous video that you can check out.
We will watch that video actually.
That it has been proven that foaming up a runway prior to an emergency landing actually doesn't really help. It's very hard to judge where exactly an aircraft is going to touch down, and even if you do, it's not going to have much of an effect. And probably the most important reason that we don't do it is because you are using up valuable fire retardant foam that you might have to use if the worst thing would happen and the aircraft would actually catch fire. So it will be very rare for you to ever see the fire department foaming up a runway prior to an emergency arrival almost anywhere in the world nowadays. Now, the weather at Los Angeles Airport as this aircraft is now initiating its approach is absolutely beautiful. The surface wind is 240 degrees at 13 knots. That's almost straight down runway 25 left, and only some few clouds and a temperature of 21 degrees Celsius. After almost 3 hours airborne and with the fuel reduced down to 4,500 kilos, which had been shown to be the optimum fuel load inside of the Airbus A320 to get the center of gravity as aft as possible, the captain, who is now taken over the role as pilot flying, initiates the approach. The reason that the captain had chosen runway 25 left is pretty simple. It's the longest runway around. It's 3,328 meters long. And the crew will need all of that runway because they're now following the procedure called landing with an unsafe landing gear. That procedure indicates to the captain that they need to do a couple of things, but after landing,
landing should be carried out on a hard surface runway using any available landing gear. Some of the runways recommended. They didn't do that. Not really. We don't really need to do that. Manual braking should be used. Reverse thrust should not be used, as it will cause ground spoiler extension. The gravity gear extend hand crank should be turned back to normal to allow the landing gear down actuators to be pressurized, and this will reduce the chance of gear collapse. If the nose gear is not available, move the CG aft, center of gravity aft, by moving passengers to the rear of the aircraft. Use elevator to keep the nose off the runway, but lower the nose onto the runway before elevator control is lost. Braking must be progressive and balanced against available elevator authority. The engine must be shut down with the engine master switches prior to nose impact. If one main gear is not available, consider crossfading to move the fuel from the wing with the unserviceable gear. The anti-skid system cannot operate with the single main gear extended and must be switched off to avoid permanent brake release. Ground spoilers should not be armed in order to maintain maximum possible roll authority.
They're not supposed to use neither the thrust reversers, not the spoilers, or the outer brake of the aircraft. So why wouldn't they be able to do that? Well, the idea is that if you're landing with the nose gear unsafe, there is a possibility that the nose gear might collapse. And if it does so, you don't really want the engines to be running when it does, because there might be parts from the nose gear, apart from the nose, that might be sucked into the engines, and the engines could then potentially catch fire.
And then you have no
So the idea
whole
is
nother
that
bag of
after
worms.
landing, you're supposed to shut the engines down. Once you have achieved a safe landing, one of the pilots, the pilot monitoring, is going to shut the engines down. And of course, if you shut the engines down, the thrust reversers are not going to make any difference anyway. But even if you are using the thrust reversers, they are actually causing more forward pressure onto the nose wheel. When it comes to the spoilers, there's probably another reason for this, and that is if you're using the spoilers and the nose gear collapses, there's a possibility that the body of the aircraft might become slightly skewed, twisted. And what you don't want to do is put yourself in a position where you've managed to get the spoilers up on the wings, but because of this skew in the body, they're now not possible to retract, and that will make it harder for the passengers who are evacuating onto the wings to actually do so. And finally, the reason that you don't want to use the auto brake system is very similar. When you start braking, that's also going to put more pressure onto the nose wheel. And here, if you have a very long runway, you can just utilize the aerodynamic braking of the aircraft and the friction braking from the wheels and not use so much braking, thus using less pressure on the nose wheel and potentially keep it from collapsing at all. So this is what the pilots are thinking about as they're now flying the ILS approach into runway 25 left. As the aircraft descends to 1,000 feet, the first officer depressurizes the cabin. This he does in order to make sure that there's no residual pressure inside of the cabin in case they have to immediately evacuate after the aircraft comes to a stop. When they pass 500 feet, he takes up the PA mic and he calls the cabin saying, "Brace, brace, brace." Now the cabin crew has gone through the cabin and instructed all of the passengers on how to do the brace position perfectly. So the passengers will now hold the brace position until the aircraft comes to a full stop. At time 18:20 local time, the Airbus A320
here we go, chat. Lock in, lock in. Lock in, chat.
Well within the touchdown zone on runway 25 left.
Lock in.
5 seconds after the touchdown, the first officer reaches over and depresses both of the fire switches, which causes the engines to shut down. The captain holds the nose of the aircraft up to keep the nose wheel away from the ground as long as possible. But he also knows that he can't do it for so long that the aerodynamic effectiveness of the elevators stop working. So eventually he lowers the nose gear down. Almost immediately, the two nose gear tires are deflated and ripped apart. The nose gear wheels are then grinded towards the asphalt down all the way to the wheel axle, and they're creating a lot of sparks and smokes that we could all see on these famous TV pictures as they were doing so. The aircraft eventually comes to a complete stop, bang on the center line of runway 25 left. And initially, the crew are waiting because they don't really know whether or not the nose gear is going to collapse. But eventually it becomes clear that the nose gear is holding up, and insteed of initiating an evacuation, they call for some external steps to
we did it
towards the front left exit, and they start disembarking the passengers through that door. Now this is something that the crew had also pre-briefed prior to the landing, because you don't really want to evacuate an aircraft unless you absolutely have to. And the reason for that is that during an evacuation, you can be almost sure that some of the passengers are going to hurt themselves. They're going to strain their wrist or maybe break an ankle or something like this. So an evacuation is something that we do as a very last resort. In this incident, none of the passengers or crew were hurt, and the aircraft only sustained some very minor damage to the nose gear, as I explained before. Actually, they replaced part of the nose gear as it was standing there on the runway, and the aircraft was then towed.
What, do they get like fucking Guido in there? And like do like a favorite pit stop? Well, like we did a pit stop on a fucking airplane.
Into hangar, where they started to investigate what the reason was for this situation to appear. And that's where they noticed through a boroscopic inspection of the nose gear that the lugs had been ripped off, the upper support of the shock absorber, like I explained earlier. And this led to Airbus changing some of the software in the BSCU, the brake and steering control unit, so that it wouldn't do as many of those pre-landing tests as it had been doing before. They also noticed the incorrect pressure inside of the shock absorber, and they started looking into why that was. That's when they noticed that when the shock absorber was being serviced, it was being done so with the entire weight of the aircraft still resting on it. And it turned out that it was almost impossible to get the right pressure in when that was the case. As a consequence of this, it was mandated that whenever the nose gear shock absorber had to be serviced, it has to be done so with the nose gear properly jacked up so that there were no weight resting on it. Now, it would turn out that this was not going to be the last time that an Airbus A320 landed with the nose gear set 90 degrees perpendicular to the aircraft. There was going to be many, many more of them, but interestingly, for many different reasons. And if you want to know more about that, I've actually done a Mentor Now video on my new channel that I hope that you have subscribed to. You can check it out up here. A Boeing 767 is on final approach preparing for landing. Inside of the cockpit, both pilots know that in a few seconds they're going to have to land their massive aircraft on its engines and belly. What has led up to this, and could it have been avoided? Stay tuned.
Porsche Airlines 516, let's do this!
Blinkist for sponsoring this video. The story of Lot Polish
How many videos do we have left, by the way?
actually started almost 11 years prior to the incident. Because in June year 2000, Boeing had started to receive reports from some of its operators that some of their Kevlar hydraulic hoses that were connected to the landing gears had showed signs of earlier than expected wear and tear. This was found to be due to the minimum radius of the...
Wait, I just want to check. Okay, I just want to check one more thing. Okay, yes. Don't wait. Please, last video. All the videos we have left. Everyone survives. Just in the story that spoiled, everyone survives.
Hose being exceeded, and they figured out a fix to this. Boeing noticed that if they added a bracket and a new swivel fitting to the hose, that would mitigate the problem. So they sent out a service bulletin to all of its operators saying that if you do this, if you fit these new parts onto the hydraulic hose system, it will solve the problem and it will extend the service life of the hose. This service bulletin, though, was a low priority service bulletin, which means that it was not mandatory and it was left up to the operators to decide whether or not they wanted to implement it. Lot Polish Airlines decided, after reviewing their own data, not to implement it on this particular aircraft. These hydraulic hoses were still subject to mandatory maintenance review every 6,000 hours, and the last time that this particular Kevlar hose had been inspected was about 6 months prior to the incident, and there was no issues found with it in that inspection. Another technical feature that you have to understand in order for this story to make sense is the arrangement of the circuit breakers inside of the cockpit of the Boeing 767. So circuit breakers are these tiny little round, what looks like buttons that are situated mainly behind both the captain and the first officer. If you go into the cockpit and you look behind them, you'll see that there are rows upon rows of these circuit breakers. And these circuit breakers, they work just like the fuses that you have inside of your house. If the electrical load that goes through the circuit breaker exceeds a predetermined limit, the circuit breaker will pop. It means in this case that it will pop out from the panel and it will show a little white ring to kind of highlight that it has been popped, and it will then cut the power to the components that are connected to that particular circuit breaker. Right? They are organized in a grid pattern where you have letters vertically and numbers horizontally. So if a pilot needs to find a circuit breaker, for example, if it's said in a normal checklist that they have to pull a specific circuit breaker, well, then they go in and they look for Alpha 1 or Foxtrot 6, for example. The circuit breaker panel that is situated behind the first officer is called P6, and behind the captain is called P18. On the Boeing 767, these circuit breaker panels, they went all the way down to the floor, and Boeing started receiving feedback that the lowest circuit breaker row was actually so close to the floor that the cleaners that was cleaning the cockpit could potentially pull out a circuit breaker by accident, or a pilot that was putting his or her flight bag in could do the very same thing. Boeing did listen to this feedback, so from the Boeing 767 with production number 863 and upwards, they fitted a kind of guard rail to protect the circuit breaker. But this Boeing 767 that was involved in this accident was number 659, so it did not come with this guardrail. This guardrail could be retrofitted for an extra cost, but that had not been done
Imagine if that's like an extra $1,000. Like, why?
on this aircraft. Late in the evening, on the
If it's
1st
more
of
than like
November
$10,
2011,
like that's
the
more like
crew
$50
of
is
LOT
bullshit.
Polish Airlines Flight 16 started to get ready for their flight from Newark International Airport in the United States over towards Warsaw International Airport in Poland. When they got out to the aircraft, it had already been inspected by an engineer from an external engineering firm, and he had found nothing wrong with the aircraft. The crew consisted of 2 pilots, there were 8 cabin crew members, and a total of 221 passengers scheduled to fly on that day. The flight crew had already done all of the pre-flight preparation. The weather in Newark was fine en route, there was no problems expected, and the weather in Warsaw was also expected to be fine, with just some high clouds around and very light winds. They decided that the captain was going to be pilot flying and the first officer was going to be pilot monitoring. The 2 pilots that are flying this flight are very experienced. The captain is a 57-year-old with close to 16,000 hours of total time and a lot of experience on the aircraft. The first officer is a 51-year-old with just over 9,400 hours of total time. The captain went outside and started doing the walk around of the aircraft, while the first officer did the safety inspection and the preliminary flight deck procedure, as was stipulated by the standard operating procedures by LOT at this time. Now, part of this preliminary flight deck preparation is to very carefully look at both of the circuit breaker panels to make sure that there is no popped circuit breakers. And the way that you do this is that you stand parallel to the wall and you look down and up. Because if you do that, it should be fairly easy to spot one of those white colors that is indicative of a popped circuit breaker. And the importance of doing this check very carefully is, of course, that if a circuit breaker has popped, it will stop potentially critical systems from functioning. So it's very important that we do this check very thoroughly in the beginning of the flight. At time 03:58, the pilots had completed all of their pre-flight preparations and they asked for push and start from their gate to start their journey over the Atlantic. 21 minutes later, at time 04:19 and 8 seconds, the aircraft started a completely normal takeoff roll from runway 04 left in Newark. Just a few seconds later, as the aircraft achieved positive rate of climb, the captain asked for gear up. First officer verified positive rate of climb and then selected the gear lever into the up position. This opened the landing gear doors, it retracted the landing gear into the aircraft, and then the landing gear doors closed. So far, nothing is out of the ordinary. The aircraft continues to climb, the crew start to accelerate the aircraft and they start to retract the flaps until eventually the aircraft is what we call in a clean configuration, which means that all of the flaps are retracted and the landing gear is retracted. Now, unbeknownst to the crew, as they retracted the landing gear, the Kevlar hydraulic hose that we talked about earlier that is connected to the right-hand landing gear developed a leak very close to where it was connected to the hydraulic actuator. This was a fairly large leak and it's quickly started to empty out the center hydraulic system. As the pressure in that system reduced, it generated an ACAS warning inside of the cockpit that said "C hydraulic system pressure." The pilots reacted to this warning, as they should, by taking up the quick reference handbook and reading through the checklist which is associated with this warning. Now, the Boeing 767 has 3 hydraulic systems, the left, the right and the center. These hydraulic systems are to a certain extent redundant. It means that if one system fails, the other systems will pick up the slack and do the same things. This is especially true when it comes to flight controls, for example, so that the aircraft can be controllable even if you lose hydraulics left, right or center. But there are a few systems that do not have hydraulic redundancy. One of those systems is the flap extension and retraction system, and another one is the gear extension system. Now, these systems have electrical redundancies instead. So this means that if the central hydraulic system fails, that's the system that takes care of both flap extension and retraction and the landing gear extension and retraction, well, then you will still be able to extend the gear. So as the pilots were working through the checklist, they found that, yeah, we will indeed have to use these alternate systems instead, but the aircraft is in a clean configuration. There is nothing in this checklist that stops us from continuing the flight towards Warsaw. In fact, it's probably a good idea to do so if we would have some problems because we need to burn off or get rid of the fuel anyway.
True.
So Once they had run through the checklist, they got into contact with their operational center and told them about the problem. And together they decided that, yeah, you can continue your flight towards Warsaw. There's no issue with that. For those of you who think that that sounds like a strange decision to take, after all, they've just departed from a perfectly workable airport, why don't they just go back in and get this thing sorted? I can honestly say that I would have likely taken the same decision as this crew did. There's nothing in the checklist that precludes them from operating over an ocean. The system failure is not really going to produce any issues for them until it's time to land. And rather than going out over the sea, dumping fuel and going back in again, you might as well use both the fuel and the time that this gives you to discuss how you want to do this. Now they have plenty of time while they're flying over the Atlantic Ocean to talk about, right, when do we want to try to extend the gear using the alternate procedure, how are we going to do with the flaps, what are we going to tell the passengers, and so on. As the flight now continued towards Warsaw, the operational team inside of Lot Polish Airlines were aware of the problem. But just like the flight crew, they didn't see a real issue with this, right? So there was no task force being set up. There was no group that was getting ready to assist them when they arrived towards Warsaw, because this is, in effect, a slightly different procedure, something that we don't do very often, but something that we practice in flight simulators quite often, actually. The captain did during the flight call the purser, the head cabin crew member, up to the flight deck and explained to him that they had an issue with the hydraulic system. But they both decided that there was no reason to talk to the rest of the crew because there was no difference in procedure. There was not going to be anything different with the landings or any risks associated with this. So at this point, the rest of the cabin crew was unaware of any issues. Before reaching the top of the descent, the captain briefed his first officer on the arrival procedure, on the approach, and the differences that would have come with the failure they had. This included taking the gear down using the alternate procedure a little bit earlier than they would normally, just to make sure that they had enough time to run through the non-normal checklist. This is something that they wouldn't have done very often. And also to make sure that all of the systems were operating correctly. Other considerations to have when you're dealing with a problem with your hydraulics is, for example, checking your landing distance, because the hydraulic systems will be connected to different flight and ground spoilers. So if an entire hydraulic system has failed, which was the case in this case, some of the spoilers might not come up, and that's going to have an effect on your landing distance. So these are the kind of things that they would have looked at prior to starting the descent. Before we get into the really dramatic part of this video, I just want to share this short message from a sponsor who makes it possible for me to produce videos.
Okay, give me a second.
5% off the premium subscription. So go down, check it out. At time 12:17 UTC, the first officer is getting ready to execute the alternate gear extension procedure. Now, this procedure involves, among other things, pushing the gear extension button. This will electronically release the up locks of both the landing gear doors and the landing gear itself. And the landing gear will then, with the help of gravity, fall out and lock into position. This is an irreversible procedure. This means that once the gear has been extended using the alternate procedure, the crew will not be able to retract the gear again. So it's really important that before you use this procedure, you make sure that the weather is good at the airport and that there's nothing else that might stop you from landing. Because of course, if you have to do a go around or stop the approach for whatever reason, you now have the gear hanging out and you're going to be burning much more fuel. But in this case, the weather in Warsaw is beautiful. It's runway 33 in use with just a really light tailwind and good visibility. So the first officer completes the procedure. But after the time it would normally have taken for the gear to extend, there is no indication that the gear is down. So the first officer brings up the QRH checklist again. He goes through all of the steps. Maybe he's missed something. But once again, it fails. The gear remains up.
Oh no.
Now the pilots are facing a completely new type of problem. The previous problem they had with the loss of the central hydraulic system was something that they had a plan for how to fix. But this thing, the fact that the alternate gear extension procedure is not working, that it has nothing to do with hydraulics. This is something potentially electric, and they don't know how to troubleshoot this at first. So the first thing they do is they abandon the approach. They ask for vectors into a holding zone to try to deal with this. Luckily, they also have quite a lot of fuel, so they have a lot of time to troubleshoot it. And they also contact their operations center to tell them about this new problem they're facing. Very soon after the approach has been abandoned and air traffic control has been informed about the new problem that they're facing, the captain also declares a mayday, 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 a full emergency call. This has the benefit of the air traffic control now starting to organize for a potential catastrophic emergency landing. They are calling in extra resources in the form of firefighting equipment. They're calling the local hospitals to have them on alert. There's also going to be a lot of medical personnel and ambulances being called, and all external personnel are gathering up at gathering points, which are predetermined points outside of the airport, so that they can be very quickly let into the airport area in case something really bad would happen. As the aircraft is entering the holding pattern, the captain is now in contact with their operations center, and he's asked for technical help. Unfortunately, the engineer that is supposed to be available via radio, because he's actually situated outside of the airport, has not got access to a working radio. So it takes about 20 minutes for this engineer to get himself to the operations center. And that, of course, is time that you don't really have in a situation like this. During this time, the crew is talking to an instructor pilot that is present there. They're trying to troubleshoot it. But it's not really until the engineer comes onto site and can start talking to them that they can start getting some actual advice on what they should be checking. Now, the engineer tells the first officer to recheck the emergency extension button once more. But when that doesn't work, he also tells him, can you go back and check the circuit breaker panel? In order for the first officer to properly see the circuit breaker panel, he has to get out of his seat. So he does so, and he gets directed to go down and check the Foxtrot 6 circuit breaker. This is the circuit breaker for the alternate extension motor. He checks it, but the circuit breaker has not popped. The engineer then tells him to pop it, manually pull it out, and then reset it again to see if that might reset the system. But he tries it, it's not working. So the first officer just gets back up, gets back into his seat, and now the crew are starting to contemplate the possibility of having to do an all gear up landing.
Oh no.
Now, if the first officer would have looked down about 30 centimeters below the Foxtrot 6 circuit breaker that he was working with, he would have seen another circuit breaker, which might have been popped at this point. This circuit breaker was in the Alpha 1 position, and it was called battery bus distribution. So the name didn't suggest that it had anything to do with the alternate gear extension motor, but it's going to turn out that it actually did have something to do with it. Now, you might ask yourself, how come the first officer missed that circuit breaker was popped? If he did, he was right there, within centimeters of the circuit breaker that he was already working on. Well, in order to explain that, we're going to do a little experiment. So, I have 2 oranges and an apple here. Your job is going to be to count how many times this apple changes hands. All right? It's really important that you keep track of it, because it's going to be important for a further exercise later on. Ready?
All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
All right. So how many times was that?
12.
Good. But did you also notice how the tail fin of the aircraft moved
I saw
the
that.
bottom of the screen, or the cats that moved behind the chair?
No, I didn't see that.
Was there anything else that changed at the same time? Write what you saw into the comments below after you've seen the video. Now, the whole point with this exercise was to show something called selective attention. That's when us, any human being really, when we are under stress and we are given a specific task, our attention is going to be focused solely on that task, right? And it's likely that we will have complete tunnel vision outside of that. So it's perfectly possible that this is what happened to the first officer. He was under a lot of pressure. The whole situation gave a lot of stress, and he was given a task by the engineering to look for a specific circuit breaker and to pull that and reset it. It is also possible that if the engineer instead would have said, can you go back and just row by row check that there are no circuit breakers that have been popped, that he would have seen that popped circuit breaker, right? But since he was given that task to go for Foxtrot 6 and work with that, the attention span was likely focused on only that circuit breaker. We will never really know, but it is an explanation. At the same time as this is going on in the cockpits, the captain has also been in contact with the purser. In fact, the purser was inside of the cockpit when the first officer was looking at the circuit breaker panel. The captain has informed the purser of the possible emergency landing that's coming up. The purser goes out, he instructs all of the other cabin crew to start preparing the cabin, and they do so by making a PA to the passengers, explaining how the brace position works, explaining what is about to potentially happen, and also how to use the emergency exit at the overwing if they need to be used, and how the evacuation is actually going to look. There is no panic in this aircraft, and that is largely down to the very professional behavior by the cabin crew, who explained it in a calm and nice way. And this just shows how important the work of the cabin crew is in emergency situations like this. Outside of the aircraft, 2 F-16s from the Polish Air Force has intercepted the aircraft, and they've done so to verify the position of the gear. And they can very quickly confirm that the gear is not down and locked.
But it's kind of terrified the passengers literally seeing the Air Force pull up.
But that the tail skid is extended. When the captain gets confirmation by the F-16s that the gear indeed is not down and locked, he does one last thing to try to get the gear out, and that is to increase momentarily the G-forces on the aircraft in case the uplocks are actually released, but the gear for some reason is stuck inside. So he pulls a little bit on the yoke that momentarily creates some G-forces that could have pushed the gear out, but in this case, nothing happens. The captain then relayed the message to air traffic control that this was likely going to become an all-gear up
Once at Chopin, Lot 16, we are unable to release the gear, looking at all-gear landing.
And air traffic control then relayed that information to the emergency service.
Emergency response 1, Chopin approach. Inbound 767, all-gear failure, and indicating all-gear up landing be advised.
That started to foam up about 3,000 meters of runway 33 in preparation for the arriving aircraft. Now, it should be mentioned at this point as well that Boeing does not recommend to foam up the runway, okay, to put extinguishing foam out, just because it doesn't really help that much. And also, when the emergency services are doing this, they're using up valuable foam that they might need in case something would happen, in case a fire would start. And it takes about 30 minutes to refuel a fire truck once it's run out of foam. But in this case, there was quite a lot of time still until the aircraft arrived, so the rescue services had time to refuel their trucks with more foam, and I guess the foam, well, it doesn't really hurt. So I would say that it probably didn't do either or for the outcome of the landing.
Shut up.
But in the whole
Be
thing,
quiet,
the crew
chat.
was now concentrating on preparing as
Don't
much
say
as they possibly
anything
could for the eventual
about what
gear
just
up
happened,
landing.
okay?
We do have sections in our flight crew training manual that does explain to us how we're supposed to do these kind of landings, both all gear up landing, but also partial gear up landing, and if we have punctures on one of the tires and so on. So it's likely that this is what the crew was briefing now. And the guidance that we are given is basically to try to land in the center of the runway as much as possible. Because with all gears up, you won't have any nose gear to help you steer on the runway. And you want to have as much margins to both left and right as possible so that you can stay on the runway, which minimizes the potential damage to the aircraft. Now, when it comes to landing technique, it's a normal landing technique, but hold off the nose until you feel that you can make a soft kind of let down of the forward part of the aircraft. But you don't want to hold it off so long that you lose the aerodynamic effectiveness of the elevator. So you do have to land the forward part of the aircraft. The aircraft will touch down on the engines at some point, so you should only use the thrust reversers if you absolutely have to in order to get the aircraft to stop. The reason for this is that as you touch down on the engines, you might damage them, so you might not get thrust reversers on one or both of the engines. And if you get it on only one, well, then that is going to, create another problem with keeping your directional control. The next thing that we have to think about is whether or not we want to use the spoilers on the wings. Flight Crew Training Manual again says that we should only really use the spoilers, actually in getting them up, if we have problems with landing distance. And the thought there is that if we touch down on the wings might become damaged, and you don't want to risk not being able to put the spoilers back down again in case you need to evacuate out onto the wings.
True.
Anyway, the pilots decide to stay in the holding until they have used down the fuel to an absolute minimum, and then they start their approach for runway 33. Before they start the approach, the captain once again talks to the purser, and he gives an unusual instruction to them. He says, tell the cabin crew to start the evacuation immediately when we come to a stop on the runway, even without my orders. So that's a little bit against the standard operating procedures. Generally, the cabin crew will always wait for the captain's command before they initiate an evacuation, unless it's obvious that it's needed, like in the case of a fire or a breakup of the aircraft or landing in water or dense smoke. But in this case, the captain gives this order, the purser sends that order to the rest of the cabin crew, and then they initiate the approach. The captain is pilot flying. They extend the flaps to 20 degrees using the alternate flap extension procedure, because remember, they still have the problems with the hydraulics. And the captain flies a picture-perfect approach in, lands bang on the center line, just as expected. The back of the aircraft touches down first, then goes down onto both of the engines. And during the landing roll, a bit of sparks comes off the engines, especially on the right-hand side, on the number 2 engine. But he maintains the center line using the rudder. The rudder is effective down to about 60 knots. He stops perfectly, center of the runway, just beyond the intersection of runway 29. When he stops, a small fire erupts in the number 2 engine, but it's very quickly put out by the fire services that were awaiting the aircraft. An evacuation is immediately started in the back of the aircraft, but in the front of the aircraft it's slightly delayed, and that's because the purser is hesitating a little bit. Because of the relatively uneventful landing, he just wants to make sure that the captain still wants them to evacuate. So he pops his head in, he asks the captain confirms, yep, we do evacuate, and about 12 seconds later the front doors are opened as well. The whole aircraft is evacuated within the stipulated 90 seconds. And the only 2 people that are left behind is the captain and the purser, who goes through the whole aircraft to make sure that there's no passengers left behind before they also leave the aircraft.
GG's,
in terms
we
of
did it.
human injuries, this emergency landing and evacuation was a tremendous success. Not a single one of the passengers or crew were hurt in the incident. As soon as the firefighters were done with looking after the aircraft, the investigation and the recovery of the aircraft started. First of all, they needed to find a crane big enough to be able to lift this humongous Boeing 767 off the ground. That took a few days, and once the crane came, they attached the aircraft to a ground power unit. The crane lifted the aircraft up, and as they were doing so, as the aircraft was hanging in the air, a team of investigators inside of the cockpit had already found the popped circuit breaker in the Alpha 1 position. So they pushed the circuit breaker back in, and then they pushed the alternate extension switch once again. And this time, the alternate extension of the landing gear worked perfectly. So already from the beginning, the investigation team had a very good idea of what had caused this. They went through the cockpit voice recorder, the flight data recorder, the witness statements from all of the people that were involved in this, and they come up with the final report. And in the final report, they state that the reason that this accident occurred was the breakage of the Kevlar hose that caused the loss of the central hydraulic system. Then came the fact that the first officer, as he was working with the Foxtrot 6 circuit breaker, did not notice the possibly popped Alpha 1 circuit breaker. And we say possibly popped because there is no indication of when this circuit breaker popped. If it was popped already from the beginning of the flight, or if it happened during the flight, or if it happened as part of the failure. Because there's no cockpit indication of a popped circuit breaker. And in this case, in this particular circuit breaker, there was no record of it in the flight data recorder either. So we will never really know at what point this circuit breaker popped, but the fact that it was out when they tried to lower the gear using the alternate procedure was what stopped that procedure from working. There were a few recommendations that came out of this investigation to Boeing. There was recommendations about the change to the non-normal checklist structure, that in case the gear was not extended using the alternate procedure, there should be more guidance to the flight crew on how to proceed. Also, it should be mandatory to install that.
Tim, you hiding secrets from me, eh? Hiding secrets from us? Ooh, no, okay.
guard for the circuit breaker panel to make sure that a circuit breaker couldn't be pulled inadvertently, and for the airline to implement the service bulletin that would have protected the
Yeah, I've totally never had an issue with copyright. Totally never had an issue with copyright. Yeah, I've never had an issue with copyright. Never had an issue with copyright. Never had an issue with copyright. I'm squeaky clean. Oh, I'm messing with you guys. I love being trolled. I love trolling.
hydraulic Kevlar hose in the first place. The aircraft was so badly damaged by the gear-up landing that it was not considered economically feasible to repair it, and because of that this is recorded as a hull loss, as in the loss of an aircraft, but with a very, very positive outcome, and that's largely because of the professionalism of the flight crew when they were flying the emergency landing, and also the great work of the
Yeah. A good example of that, like, at one time I reacted to like these videos by this YouTube channel called Huggabees, like you know, the How It's Actually Made guy, and the videos I reacted to were exact same videos that this other YouTuber CG5 actually reacted to on stream, and he posted that video of him reacting to them on stream onto YouTube, his YouTube channel, right? His video was fine. He was able to post it. Mine, it got blocked for copyright. Again, I reacted to the same videos that CG5 reacted to, the same parts of those videos that CG5 reacted to. His video was allowed to go on YouTube, mine wasn't. What the fuck?
cabin crew and also the passengers in the back of the aircraft. Do you guys know that I have a second channel called Mentor Now? Well, I do, and on that channel I do videos about...
Wait, do I still have the video? I think I did make an appeal. I did make an appeal that just got blocked. No, it's not that. I want to try and find it. I'm gonna have this video on, but then also have this. This video is British Airways Flight 009, one of the best ones.
This video is brought to you together with Skillshare. Use the link in the description below for a special deal just for you. It's evening on the 24th of June 1982. The sun has just set and darkness has fallen upon the Boeing 747-200 from British Airways, which is cruising along at 37,000 feet over the eastern Indian Ocean. The flight crew has settled back into their seats after a nice meal when they suddenly start seeing the most incredible display of St. Elmo's fire over their windscreens. As they're looking out over their wings, they can also see that the same type of glow is engulfing the entire aircraft and also coming out of their engines. It is incredibly beautiful, but also, as it turns out, incredibly dangerous, because as the pilots are trying to figure out what it is they're seeing, the first engine flames out. What happens after this is an absolutely incredible story, and it is the story of British Airways Flight 009. Stay tuned.
Actually, in the
British Airways Flight 9 was the third leg on a flight that had originated in London in the United Kingdom, and then the aircraft had proceeded via Bombay to Kuala Lumpur,
I'm trying to
where
find
this
this.
flight starts, and it was supposed to continue via Perth, then to Melbourne, and then finally inbound to Auckland, New Zealand. The aircraft being used was a 3-year-old Boeing 747-200 equipped with 4 Rolls-Royce RB211 jet engines. On board the aircraft, as it departed from Kuala Lumpur, was 247 passengers and 15 crew members. And most of those passengers had actually been on board from the very beginning in London, but the flight crew had boarded in Kuala Lumpur to fly the leg over to Perth in Australia. In the cockpit was a relatively young but still very experienced flight crew consisting of 41-year-old Captain Eric Moody. Together with him was 32-year-old Senior First Officer Roger Greaves and 40-year-old Senior Flight Engineer Barry Townley Freeman. Captain Eric Moody had started his career way before as a glider pilot, and that's going to actually turn out to be quite important during this incident. During the pre-flight preparation, when the pilots got their briefing material together and they started looking at how the flight was going to progress, it looked like the weather was...
Okay, I found it. Oh, okay. I'm gonna show you the shit. So, this is a email I got about the Pew. So I made a Pew about this. Yeah, so this is what the video I made was called. And it got denied. I'm just gonna search this. Okay, yeah, I did this on a live stream. And that's literally exactly what he did. He did this on a live stream, man. Where's the way to check appeals? Yeah, I made an appeal. Basically saying like, hey, you blocked my video. These are the same videos that YouTuber CG5 reacted to. And his video is allowed to be up on YouTube. And I kind of feel like you're picking favorites because he has way more subscribers. Let me check. I'm just gonna check. How many subscribers does CG5 have? 9 million subscribers. Like, so, like, you're just basically picking favorites here. Probably because CG5 gives them more money. Well, I don't. And that's basically all they care about nowadays. Money. Which is why I think they're picking favorites. So yeah, like, really annoying.
going to be quite nice. There was only some light clouds, but generally no turbulence forecasted and no adverse weather in the briefing. And it looked like the flight was going to take about 5 hours over towards Perth.
And we went to the airport, and the airplane was a little later coming in. So instead of rolling down the runway at 7, I think it was 7:30 before.
I guess ready for the real British shit.
Took off. There was nothing abnormal about the night. It looked like a lovely, pleasant night's ride down to Perth. It was about 5 hours flight time. So it was my sector, and eventually we trundled down the runway. I made a point of saying it was half an hour later than it should have been. Well, that had a great significance on what happened to us later on.
Captain Eric Moody decided that he was going to be pilot flying for the first leg, so the crew went out to their aircraft, they boarded the passengers, taxied out, took off normally, and then started climbing down south over the Indian Ocean. The first part of the flight was very nice and routine. The crew was cleared up to their cruising level of 37,000 feet. Once they had achieved that, they kind of relaxed back in their chairs a little bit. They were served dinner because the time was now about 20:15 local time. And they joined up with the airway Bravo 69, which
nice. 69 nicer than the chat.
On a route just south of Jakarta. But what the crew didn't know was that beneath them, on the island of Java, a volcano called Gulangong had had a continuous eruption for the last few months. And during that eruption, the volcano had been throwing out loads of lava and volcanic ash high up in the atmosphere. Now, at this time, there was very little knowledge about what kind of effect volcanic ash could have on the aircraft engines. So there was no notice going out to any of the pilots or the airlines about an active volcano in the area. After Captain Moody had finished his meal, he needed to go to the toilet. So before he handed over the controls to First Officer Roger, he took a last scan on the weather radar, and the weather radar showed absolutely nothing. So he got up, handed over the controls to First Officer, went out of the cockpit, and when he went to the crew toilet, he found out that was occupied. So instead he took the stairs down to the first class lounge in order to look for a toilet there. And when he reached there, he started chatting with one of the flight attendants about, how life was, something that we tend to do when we go out and visit the toilets. But he had only started chatting to the flight attendant when he was abruptly called back up to the flight deck again by one of the other cabin crew that was still up in the crew quarters. And as he started to walk...
what the fuck is happening?
Walk up the stairs again, he noticed that
my laptop is freaking the fuck out. Chat? Give me a second. You can still hear me. Well, nothing's working. Yo, can any of you still hear me? So, if you can hear me, I just had some slight technical issues. Sorry. So, basically, my laptop right now, which is the thing I'm using to stream right now, is a touchscreen. And sometimes this is a very rare thing that happens, but it has happened sometimes. And like, it's sometimes like the touchscreen freaks the fuck out and has like multiple different things. Like, it shows like when you like touch the screen, it shows like or like indent or something, or whatever you want to call it, where like you're actually touching the screen. It showed multiple of those on the screen at the same time when it literally was not touching the screen. My hand off the keyboard, off the mouse, off the screen. And it was doing that. So I was literally could not click anything. I couldn't switch tabs, couldn't do nothing. Keyboard was not working. So I tried like closing my laptop lid, right? Didn't do nothing the first time. Tried closing it again for a second time, this time for longer. Second time I did that, it opened, then this both, since I'm using my TV and my second monitor, which is what I have OBS open on, with the TV screen and my laptop screen went completely black, and asked me to re-sign into my laptop. I'm like, great. So yeah, and then I just like shut stream off for a second. So yeah, that just happened. So many technical difficulties on the stream, goddamn.
At the vents, the floor vents that is just next to floor level, that there was white smoke puffing out of those vents.
The stewardess who'd been in the first class, in the upstairs loo, which I tried to get in, came halfway down the stairs and she said, "Captain, you're wanted upstairs on the flight deck." So I went up the stairs, and the first thing I noticed then was that around the lower part of the walls where the air conditioning air comes in, it seemed to be billowing in smoke. And I could smell this acrid electrical burning smell. So I thought, oh dear, I'm going to go on the flight deck and they're going to say, can we fire the fire extinguishers in the electronics bay or something? But nothing was further from the truth, because I went through the door. The other two said, come and look at this, it's beautiful.
When he entered the cockpit, he was greeted with a display that he had never seen before.
Yo.
There was what looked like St. Elmo's fire everywhere over the windshields. St. Elmo's fire is an electrical phenomenon that tends to happen when we fly close to electrically charged particles. So, for example, close to thunderstorms or so, where it looks like a pattern of lightning that moves over the windshield. Now, St. Elmo's fire in itself is not dangerous. In fact, it's quite beautiful. But it does indicate that you tend to be close to thunderstorms. So Captain Eric went back, sat down in his chair. He was very happy to see that the crew had already switched on the continuous ignition on all 4 engines. And he started scanning the weather radar in front of him. But to his amazement, there was no thunderstorms around. In fact, the weather radar was just as clear as it was when he left the cockpit just a few minutes earlier.
When you're going in the flight deck, you see this, you go to sit down. Well, I'm getting into my seat. I'm twiddling the radar to see where this, well, I thought there had to be a big QNIM somewhere and we were in the thin cloud at the top because I thought you needed moisture. Because we usually see it in the tops of high QNIMs or other, or when you're on the ground and on the diffuser run the engines up in the winter, you get fog, you can get St. Elmo's fire, and that's what I thought it always had to happen. Yeah. And I mean, I've never seen it like that before. And well, as I'm buttoning my seatbelt up and I'm fiddling on the radar, I could see no clouds around.
I'm not sorry
before I left
the
the
British
seat,
moment.
I checked the weather.
But this incredible show of St. Elmo's fire just continued, and as the crew started looking outside of the cockpit back towards the wings and the engines, they realized that there was this bluish glow coming from the leading edges of the wings and also from inside of the engines, creating a very strange stroboscopic effect that, together with the turning fan blade, looked like the fan blades was kind of moving slowly backwards. The pilots had never seen anything like this before, and when they started looking forward towards their windscreen again, they realized that the St. Elmo's fire had been replaced with something that looked like trace fire. If you've seen images from war zones, for example, you know that when they shoot with certain guns, every, 100 bullet or so is a trace bullet that gives those kind of glowing track lines. That's trace fire. And that's exactly what it looked like on their windscreen. But Captain Moody, he was worried about other things because he had seen that whitish smoke that had been coming out from the air conditioning vents, and he knew that smoke in an aircraft is never a good thing. So he had started thinking about what to do about this. But before he could even finish that thought, Flight Engineer Barry called out, "Engine failure, engine number 4. The time was now 2040 local time, and this announcement by the flight engineer took the situation to a completely new level.
Oh shit.
Captain Eric called out, okay, engine failure and shutdown checklist please. And flight engineer Barry started executing that checklist, and that included items like putting the thrust lever back to idle, the engine start lever to cut off, but also in British Airways pulling the engine fire handle, right? Not actually putting any of the extinguishers into the engine, but arming them so that they were ready to use in case they would be needed. As soon as the engine failure shutdown checklist was completed for the number 4 engine, Barry shouted out again. This time he said, engine failure number 2, 3 has gone. They've all gone. So this means that in a matter of a few minutes, this Boeing 747 had gone from a completely controlled normal flight into a flight where now all 4 engines had simultaneously failed. This is a potential catastrophic situation, and the way that the flight crew handles this from this point on is going to be crucial for how successful they are with recovering it. Captain Moody was stunned by this announcement, and he looked down onto his engine instrumentation, and what he saw was a very confusing picture, because on the Boeing 747-200 at the time there were 2 sets of different engine manufacturer indicators. So there was both Smith instrumentation and General Electric instrumentation, and some of them showed the engine values frozen where they were when the engine failed. Other ones went off the scale, making the picture that he was seeing almost impossible to get your head around. And another thing that made him very confused was that he had actually practiced a quad engine failure, as in 4 engine failure scenario in the simulator a few months earlier. But when they did that, almost all of the lighting in the cockpit disappeared, together with all the instrumentation on the first officer's side and some other system. But in this scenario, it seemed like at least one of the engines and the generator connected to it was still producing power, giving it a completely different sensation than what he had had in the simulator
With the
earlier on.
freak.
And here, Captain Moody makes a very important decision, because when he looks down on his primary flight instrumentation, he realizes that his speed is starting to tick down. Something that you would expect from an aircraft maintaining 37,000 feet without any engine power. And he also realizes that because he still has some electrical power coming from one of the generators,
Welcome back.
the autopilot is still working. So he puts the aircraft into a shallow descent, just enough to maintain the airspeed. So he is now focusing on flying the aircraft, making sure that the aircraft doesn't go into a stall and that he has complete control over it. He also initiates a left-hand turn back north again, okay? Because remember, they have passed the city of Jakarta a few minutes earlier, and they're now out of the sea. If he makes a left-hand turn, he will start heading back towards land and towards a potential airport. He also tells the first officer, Roger, to please send out a mayday call. So at time 20:44, this is 4 minutes after they started seeing the first lights in the cockpit, the following call is made to Jakarta control. Jakarta, Jakarta, mayday, mayday, Speedbird 9, we've lost all 4 engines. We're leaving flight level 370. Initially, air traffic control didn't fully understand this message. They thought that they heard that they had lost engine number 4, which is very different from having lost all 4 engines. But that kind of miscommunication kind of makes sense when you think about the likelihood of hearing that an aircraft has lost all 4 engines. That just doesn't happen.
Yeah.
The engineer and myself went through the first checklist, and I detailed the co-pilot to send out the mayday call, which is when he had the first problems, because there was so much static around the aircraft for obvious reasons that his communications were intelligible. And it took a little while to get through to the Jakarta Air Traffic Control, who's English. I mean, we're talking about 1982. You go out that way now, it's not fantastic. But in 82, it was even worse. And he had great trouble getting through to them because it was a non-standard phrase. All 4 engines had failed. If he'd said number 4 engine has failed, they might have understood that. But he said all 4. And eventually, it took a Singapore Airlines aeroplane, who was about half an hour behind us on the same route, to relay to them, no, they have no power going. No power.
What has actually happened here, which I'm guessing most of you have already guessed, is that the aircraft has flown into a layer of high-altitude volcanic ash. Volcanic ash is spread from a volcano basically in 2 different ways. So you have the main black plume. That's what you're all thinking about when you're thinking about.
Oh, I'm gonna get some popcorn real quick. Be right back, chat. We are back. We are back. We are so freaking back. We are so back. We're ready to continue.
On volcanic eruption, which is mainly pieces of brimstone, ash, lava, stones that are being thrown out on top of the volcano. But then, higher up, this gets separated into the finer kind of ash dust. And this tends to be whitish in color. If you've ever seen a satellite photo of a volcanic eruption, you tend to see the black main plume going one way, and then you'll see a slight white cloud going a slightly different way. This whiter cloud tends to be containing smaller particles, down to as small as 1 micrometer, and it can travel hundreds of kilometers away from the main volcano. It can also be included in cloud masses and so on. These particles are electrically charged. That's why you sometimes see these lightning bolts from a volcanic eruption. But this is what caused that St. Elmo's fire that the flight crew saw, and also the lights from inside of the engine. The reason that the weather radar didn't show anything was because the weather radar is not designed to pick up particles as small as the volcanic ash particles are. Remember, volcanic ash can be as small as 1 micrometer, and most of the particles at those altitudes are not much bigger than that. And because of that, the weather radar, which is designed to pick up moisture and droplets, didn't see anything. In order to see things like volcanic ash, you would need a weather radar with a very different wavelength, okay, a smaller wavelength. But the weather radar on board the 747-200 did not have that, hence Captain Moody did not see anything on his weather radar, even though he was surrounded by large concentrations of volcanic ash. If someone was trying to create a material that was solely designed to disrupt aircraft systems and be damaging to aircraft, then volcanic ash would be pretty close to the ideal
Don't get
material.
any ideas, chat. Don't get any
Because
ideas.
this type of volcanic ash will not just attack one system, it will basically attack all of the aircraft systems. So the main threat obviously is what it's doing to the engines, because these tiny little particles, if you look at them with your naked eye, it looks kind of like baking powder, right? Or baking flour. But if you use a microscope, you will notice that they tend to be mostly silicates. And these silicates are extremely sharp, making this material very abrasive. So the first thing that will happen to the engines is that the engines are sucking in enormous volumes of air. And that means that it will concentrate the volcanic ash inside of the engine. And this abrasiveness will start to wear down the fan blades, the compressor blades, and the turbine blades, changing the aerodynamic property of these blades, causing things like engine stalls. But as the ash goes further into the engine and into the hot part, the melting point of these silicates is around 1100 degrees Celsius, while the normal working temperature of a jet engine inside of the core can be as high as 1400 degrees Celsius or higher.
Oh, shit.
So this means that these silicates are now melting into glass, and this will get stuck onto the igniters, onto the fuel nozzles, and onto all of the hot parts, the turbine blades and so on, that's coming after the hot part. And this can stifle the engine completely. But on top of that, this high abrasiveness of the volcanic ash will start sandblasting the outer part of the aircraft. So the aircraft's windows, for example, the pitot tubes, the static probes, the angle of attack vanes, all of those can be damaged, causing faulty instrument readings inside of the cockpit. And then the volcanic ash will get its way in through the air conditioning ducts, for example, stopping vanes and valves inside of the air conditioning and being pumped into the aircraft, where it will smell like sulfur, or that acrid smell that Captain Eric Moody felt. Also, it's going to be irritating for eyes, people breathing it in. It's not good for anything. But it also goes into the fuel tanks through to the vents, the air vents, where it contaminates the fuel. So all in all, going into a high-level volcanic ash cloud with high concentrations of ash is a very, very bad thing for the aircraft.
Yeah, indeed.
The flight crew knows nothing about this, so they are now working frantically on trying to restart the engines. And they're discussing whether or not they're going to try to restart engine number 4 as well. Remember the one that they did the engine failure and shutdown checklist for, because they pulled the fire handle. And if you pull the fire handle, then that engine will not be restarted unless you push that fire handle down again. And together they say, well, we have very little to lose from trying to restart it. So they continue to try to restart all 4 of them, but none of them start to begin with. Instead, as the crew now descending through about 26,000 feet, the cabin altitude warning goes off. That's because the pressurization in the aircraft works with using bleed air from the engines, and since none of the engines are working, there's no bleed air being fed to the aircraft, which means that the pressurization inside of the cabin is starting to leak out in various ways, and the cabin altitude has now reached over 10,000 feet. This means that the flight crew needs to get on oxygen quickly, because they won't be able to last for very long without starting to suffer from hypoxia. So they call for it, they put the masks on, but when the first officer tries to put his mask on, it turns out that it hasn't been fitted properly. So it basically falls to bits in his hands. So Captain Moody is now faced with a very hard decision. Either he can try to maximize his glide using his own oxygen, but risking that his first officer will succumb to hypoxia and become unconscious. Or he can go in and he can do an emergency descent, in which case he would potentially lose, very valuable altitude, but he will have the benefit of his whole flight crew with him.
True.
He decides on doing the emergency descent, which means that he's now pitching the aircraft forward into a dive. But as he's doing this, the standard operating procedure for the 747 to do this would be to lower the landing gear as well, to get maximum drag during this maneuver. But he discusses this with his fellow pilots, and they decide not to do this because they know that lowering the landing gear will require a lot of hydraulic fluid. But none of the engines are working, which means that they don't know how much hydraulic pressure they have. And they don't want to risk lowering the landing gear and then not having any flight controls to control the aircraft. So they decide to keep the landing gear up. They start diving. And here's also where Captain Moody realizes that there is a difference of indicated airspeed on his airspeed indicator to what is shown on his first officer's one. Remember how we talked about how the volcanic ash can come into the pitot tubes? Well, in any case, he decides that his, which is showing around 320 knots, is probably the one that is working better. So he decides to focus and continue to use his own airspeed indicator. This type of discussion that the flight crew is now having about very complex systems and how these systems might react in a situation they've never faced before shows a very good understanding and situational awareness of the aircraft. And on top of this, First Officer Roger, as they're now descending, has managed to fix his own oxygen mask, so he can now put it on and get oxygen properly. And this means that as the aircraft is descending past about 20,000 feet now, the crew levels off the aircraft, continues to descend, but not with such a rapid descent rate anymore. Because now they're facing the next problem. And the next problem is that the mountains ahead of them, between them and Jakarta, are quite high. They have a safety height of 10,500 feet. So the crew needs to decide whether or not they can actually glide past these mountains safely. And what they decide is that if they reach 12,000 feet and they haven't managed to start any of the engines, which means that they will continue to descend, well then, instead of trying to transgress the mountain range, they will just make a right-hand turn out of the sea again and try to ditch the aircraft in the water.
Oh no.
And this consideration was another reason that Captain Moody didn't want to lower the landing gear, because he knew that if he had lowered the landing gear, he wouldn't be able to retract it, and if he would have to ditch the aircraft in the ocean, he did not want to do so with the landing gear selected down. The crew continues throughout this entire descent to try to relight the engines. They take turns trying each engine to see if one would start when the other one wouldn't. But initially, none of them will start. However, when they're putting fuel into the engines are actually igniting. They're just not starting up properly. But that has a secondary effect of showing flames coming out to the back of the engine.
Oh,
so this
shit.
means that the poor passengers that are sitting at the back of the aircraft, they, if they were looking out of the wings, would be shown of a display of 4 engines on fire, which would be absolutely terrifying.
I bet.
And with this in mind, Captain Moody decides that he needs to make a PA. Right? He needs to say something to the passengers to reassure them. And the PA he makes is probably going to go to the history as one of the most understated PAs ever made.
I said, well, if I'm going to talk on the passenger address, I'm going to talk to the passengers as well. They're going to hear everything I say. So really, I suppose I've got to sound laid back, laconic, in control, and I have to tell them something. But what do I tell them? And my intent was to get the attention of the CSD and the cabin crew, and I got the attention of the world's press. And I didn't intend to do that, but I did. And I said, ladies and gentlemen, this is Captain Eric Moody again. We have a small problem in that all 4 engines have failed. We're doing our utmost to get them going. I trust you're not in too much distress. And would the CSD please come to the flight deck? And that little bit at the end is a signal in British Airways for the cabin crew to prepare for a crash landing or a ditching.
After the PA, the cabin crew is invited into the cockpit, and Captain Moody is trying to give them a briefing about what's going on, but because he still is wearing his oxygen mask, he finds it very hard to communicate. And the purser doesn't hear anything of what he's saying, but he understands that he's actually, doing more harm than good in the cockpit, so he just nods and gets out of the cockpit, goes down to brief the rest of the crew about a potential emergency landing. The jumbo jet is now getting close to their cutoff altitude of 12,000 feet, and Captain Eric is starting to think about the possibility that they might have to ditch this huge aircraft in the ocean. And he's well aware that trying to ditch an aircraft of this size at night, where it's extremely hard to judge the height over the waves, has a very low likelihood of succeeding. But as he's starting to contemplate this, he's interrupted by the jubilation from his fellow crew members when the number 4 engine starts up. Remember, the first one that they shut down? That one is now starting up. And after that, in fairly quick succession, they managed to start all 4 engines. So initially, they reduced the descent rate. With the second engine being started, they can start a very shallow climb, and then eventually they have all 4 engines available to them. And Captain Eric now wants to get up, get away from the mountains and get precious altitude as quickly as possible. And this is not the end of the troubles for this crew.
Sorry about that, my
I'm
dad
going
was
to
in
tell
my
you
room.
all about it after this short message from my sponsor.
No.
At time 2057, that's 17 minutes after the crew first started seeing the St. Elmo's fire outside of the aircraft, the first officer called up Jakarta Control with the following message. Jakarta Speedbird 9, we're back in business, all 4 engines operating. The crew was now anxious to try to climb up to gain some precious altitude again, because remember, they didn't know whether or not the engines would fail again on them, and if they could get a little bit more altitude, it meant that they could potentially climb over the mountain range and reach Jakarta. So they put some extra thrust on the engines, they started climbing, and when they reached about 15,000 feet, the St. Elmo's fire phenomenon was back on the windscreen. And as they leveled off at 15,000 feet and the thrust came back, the number 2 engine started vibrating so violently that they thought that it was going to seriously damage the aircraft. So they reluctantly shut down engine number 2 again.
Shit.
Now remember, the crew still doesn't know why this is happening, but Captain Moody is now starting to kind of put two and two together and think that this phenomenon that's causing the St. Elmo's fire outside maybe has something to do with the engine failures as well. So he decides that they need to get out of it. They need to descend back down to 12,000 feet where they know that this phenomenon was not there. Before we go any further, I just want to give you a possible explanation to why the crew was actually able to start the engines again.
Alright.
Remember how we talked about how the ash would melt and stick to internal components inside of the engine? Well, it is very possible that as the engines were cooling down after the failures, this melted ash started to get really hard. And as they were trying to restart the engines, it broke off the internal components, enabling the rotating parts to start rotating again, and thus enabling them to start the engines. But now, since the crew has once again entered the ash cloud and now the engines are starting to heat up again, it was really crucial that they descended out of it as quickly as possible. The crew now asked for the weather in Jakarta. The weather in Jakarta was beautiful, clear sky, no clouds, light and variable winds. So they started receiving radar vectors in towards Jakarta. They were very reluctant to change the thrust setting because they knew that the engines were operating at the thrust setting that they had. So instead they were using drag, like speed brakes for example, to control the speed and the descent rate of the aircraft. They were vectored in for a traffic circuit in a right-hand pattern in towards Jakarta, and as they were turning in towards the runway, they realized that they had real problems seeing the airport. No matter how they tried to look for it, even though it was clear outside, they just could not see the runway. And they very quickly realized that the reason they couldn't see it was because their windscreens was completely opaque. They were completely sandblasted and was like looking through a shower curtain. But they managed to find on both the right and the left-hand side a small strip of windscreen which they could look through. The next problem here was that the ILS in Jakarta had an inoperative glide slope. So they didn't have an ILS, an instrument landing system, available. Instead, they had to fly a localizer approach, which would have been normal procedures if it weren't for the fact that even as they get closer to the minima, they wouldn't be able to see the runway. So the crew worked together. Captain Eric was flying the localizer, getting distances and altitude checks from the first officer, and basically descending based on what the first officer was telling him, creating kind of a virtual glide slope. Very much the same way that we fly constant angle non-precision approaches today. And in interviews later on, Captain Moody has described the way that he had to fly this localizer approach without being able to see the runway. It was like negotiating your way up a badger's ass, which I thought was a great way of explaining it. Anyway, as they got closer to the runway and Captain Moody could look out through that little strip of window that he could see, he managed to get the aircraft down towards the runway. But it felt like an eternity before the landing gear finally touched the ground in a really nice, smooth butter landing.
Butter!
As the aircraft
Let's
touched
go.
down, the crew received what is potentially the world's most deserved applause and jubilations from the passengers in the aircraft. This is an amazing feat. It's an amazing show of teamwork. It's an amazing show of communication, situational awareness, and airmanship. Now, the crew then decided that they wanted to try to taxi the aircraft off the runway. But as soon as they turned off the runway and they were faced with the lights from the apron and from the terminals, it basically just flooded their completely opaque flight deck window. So instead, they just stopped the aircraft and asked for a tugger to pull them in towards their parking position.
The windows have gone opaque, even down the side, because they were all sandblasted, but the front ones to a greater extent. So when we turned around, I couldn't see out. I couldn't see the side of the runway, and he had to taxi it back. We got to and turned off, and once we faced the terminal neither of us could see out. So we just stopped it, switched the engines off. And I went downstairs to, while we waited for the tug to come out, just to talk to the first class passengers. And there was actually an old captain in there, an old BOAC captain, who wanted to tell me the story about he'd lost 4 engines on the Lancaster over Bermuda during the war. I just didn't want to know, but there we go. He was He didn't think it was anything fascinating. And I sat on my hands, as one does on a table in the middle of the flight of the first class cabin. And when I got back upstairs, I was getting in my seat
Yes.
to be towed in. And I looked at my hands and I said to the other two, look at that, black. And the engineer said, I reckon that's volcanic dust.
There were several days before the crew was told the reason for their quadruple engine failure, but they had kind of figured it out already. As they disembarked the aircraft, they noticed that there was a lot of volcanic ash on the whole aircraft. The airspace around the active volcano was closed down for a few weeks, but then opened up again. And only 19 days later, Singapore Airlines Boeing 747 flew into the same area and had to shut down 3 of its engines. And after that, they permanently closed down the airspace until the volcanic eruption had subsided. What happened to the flight crew then? Well, the flight crew was given several commendations, among them the Queen's Commendation for valuable service in the air.
Wow.
And a couple of medals from the British Airline Pilot Association. The 747 in itself was ferried back to London a few days after this incident, where they replaced one of the engines, and then it continued to operate for British Airways for several years, before it went over to the ownership of European Air Charter, and then finally was taken out of commission in 2004. This incident and other incidents involving volcanic ash really opened up the eyes to the aviation industry about the dangers of flying into volcanic ash. So it had a huge impact on the way that we are training in the simulator now, where we have regular training scenarios on how to effectively deal with if you for some reason fly into an ash cloud. What has been shown is that what's really important is to exit the ash cloud as soon as possible and try to maintain as low engine thrust as possible in order to get the core temperature of the engines down when you're escaping. If a flight crew today would enter into an area where we believe that there might be a high concentration of volcanic ash, we are taught to do the following. We turn around 180 degrees around. We set a lower altitude on our mode control panel. We hit level change so the aircraft starts descending, and then we disconnect the auto throttle and close the thrust levers, right? So make sure that we have minimum thrust, and then we continue to hopefully get out of the ash cloud, deal with any engine malfunctions that we might have, if there might be increases in exhaust gas temperature, or if the engine stops responding to thrust lever input. There are checklists to do this. But the important thing here is that we know what to do if we see these telltale signs that the crew of British Airways Flight 9 encountered. Also, the meteorological services around the world are now very keen on checking if there is a volcanic eruption somewhere to predict where the ash cloud might move and to declare those non-fly zones. Okay, we all remember what happened after the volcanic eruption on Iceland, which basically stopped the aviation business in Europe for several days. But now we are also better at predicting this, all right? We're better at knowing where the ash clouds are and completely avoiding them. So once again, this was an incident that has made the aviation world safer. It's made our understanding about this particular phenomenon better. And that's what I wanted to give you through this video. As always, guys, I hope that you have enjoyed.
Final video of the night, chat. It's been a long stream.
An Airbus A320 is taking off from LaGuardia Airport in New York, runway 04, and only a few minutes into the flight, they encounter a large flock of birds.
And this is probably one of his most unique videos because it had because it's the only video of his that I think I know of. It had a full uninterrupted flight simulation of the actual event happening. And so when we get to that, I'm just going to shut up and let it play. I'm going to mute myself and just let it play.
Now, several birds get ingested into the jet engines, making them unusable, and the pilots find themselves with only a few minutes to...
Why? Because this is the miracle on the Hudson. One of the most well-known incidents ever. Sully. You know Sully.
Save themselves and everyone on board. This is the amazing story of the miracle on the Hudson. US Airways Flight 1549. And I'm going to tell it to you from my perspective. Now, before I start this video, guys, I want to make a huge shout out to my Patreon crew. Now, I wouldn't be able to sit here and create this kind of content for you guys if it weren't for the support. It's probably one of the most heavily publicized stories for the last few decades. There have been Hollywood movies made about them.
The year I was born.
Of articles,
the year I was created
in all over the world.
Forcefully,
but what I am going to give you is the insight from
and
a
everyone's
pilot's
life will live in
hell. I am
hell.
going to tell you this story based on the final report of this incident. I have linked to the final report down here. It's almost 200 pages of great content.
200 pages? Oh, hell nah.
If you're interested in reading it, and any other sources that I'm using are also linked to in the description of the video.
I bet.
So, US Airways Flight 1549, or their official call sign Cactus 1549, took place on the 15th of January 2009. There were 150 passengers on board, including one infant in the lap of his mom, and 5 crew members. The captain of the flight was Captain Chesley Sullenberger, a very experienced ex-military pilot, and assisting him was an equally or almost equally experienced first officer called Jeffrey Skiles. The aircraft is an Airbus A320 equipped with 2 CFM56 engines. This flight was the last flight on a 4-day kind of route for the crew, so they were basically going home, and this was the second flight on the day of the same aircraft. On the CVR, the cockpit voice recorder, since this was such a relatively short flight, meant that you could follow the whole CVR recording from when the pilots were doing their pre-flight, and you can tell that the pre-flight was just normal. It's actually a little bit spooky looking at the pre-flight from a pilot's perspective, because you can see how these guys obviously had no clue about what was going to happen. They were joking around, some minor mistakes were being made with the load sheets that was being, corrected by ground load control. There was some issues with Jeff's transmission button on his side that they were talking about putting into the tech log, and kind of minor things like that. So the aircraft taxied out for a takeoff runway 04 in LaGuardia Airport, New York. Everything looking completely normal. The first officer, Jeff Skiles, was the pilot flying for the leg. He was the one that was on actually fly the aircraft. And taking care of the radios and doing the pilot monitoring work was Captain Sullenberger. Now, before we go into the actual flight, there's a couple of things that I want you to know, all right? The first thing is about First Officer Jeffrey Skiles. So, Jeff was a very highly experienced first officer. He had more than 15,000 hours, and he'd flown on many types before, including the Fokker 100 and the Boeing 737. But he had just started flying the Airbus A320. In fact, he had just done his skill test on New Year's Eve 2008, only 16 days before this flight, and he had only clocked about 37 hours on the day of the accident. Right? This is going to be important in the way that he deals with his role.
Yeah, this story is insane.
Incident. The other thing that I want you to know about is this aircraft, right? In the fleet of US Airways at the time, you had Airbus 320s that were equipped for extended over water use, and aircraft that were not, right? The difference between the two was that the aircraft that were equipped to fly over water had life vests for all of the passengers on board, but they also had special emergency exit chutes that could be used as emergency rafts if needed. And those were connected both on the forward to emergency exit and the aft to emergency exit. So just out of pure luck, this aircraft on this day, even though they were not scheduled to fly over water, was one of the aircraft that was equipped for extended over water use. At the time, 15:24:54, because actually the seconds are important here. Cactus 1549 received their takeoff clearance on runway 04.
Also, if you didn't hear it because of me yapping, Cactus is the official call sign of US Airways 1549.
Started rolling down the runway, everything looking fine. Jeff made a normal takeoff, And at about 700 feet, they changed controller from the tower controller in LaGuardia to the departure controller in the New York area. Captain Sully checked in on the radio, stated that it was 700 feet, climbing to 5,000 feet, and the controller read back that he was clear to continue to climb to 15,000 feet, which was then acknowledged. Now, about 2 minutes into the flight, you can hear on the cockpit voice recorder how Captain Sully calls out birds, followed almost immediately by the sound of some kind of muffled thumps on the CVR and the sound of the engines rolling back. The aircraft is now at 2,815 feet and about 4.5 nautical miles north-northeast of their takeoff runway in LaGuardia. Now, what has actually happened at this point is that the aircraft has impacted with a flock of migratory Canada geese. Okay, a Canada goose is a large bird. Right? It can weigh up to about 8 pounds. And that's important because during the certification of the Airbus 320 and the CFM56 engines, they have been certified to be able to take bird strikes. But the birds used during the certification for testing purposes only weighed about 2 to 2.5 pounds. So a Canada goose is almost 3 times bigger than the birds used for certification. During examinations of the engines after the accident, it was found that at least 2 Canada Gs was ingested into each engine. One of them seemed to have hit the outer part of the fan and then subsequently been thrown out through the bypass duct, but at least 1 goose in each engine went straight into the engine core, damaging the inlet guide vanes and also damaging quite a lot of the first part of the low pressure compressor. Now these damages in themselves would have made sufficient damage to the engines to flame them out and to make them unable to start up again. But of course, the pilots up in the front of the aircraft had no idea about the damage that the engines had suffered. Now, immediately after the bird strike, the CVR, the cockpit voice recorder, is picking up the First Officer Jeff Skiles saying, "Uh-oh," and Captain Sully saying, "We have both engines are rolling back." Okay? It's important because the quicker that you realize what's happening to you, the quicker you can start acting on it. You would definitely feel, if you're doing the climb out in a Boeing 737 or an Airbus 320 and you lose both engines, the aircraft will feel like it's basically almost hitting a wall, right? It loses all momentum forward. So to figure out that you have a problem with both engines would probably be fairly easy to do. But what happens next is really impressive. And that is only 2 seconds later, Captain Sully says, "I'm starting the APU and I have controls." The fact that he is taking controls is normal. It's normal procedures by US Airways at the time that the captain takes control during a situation like this, letting the first officer become the pilot monitoring and dealing with subsequent checklist. But what's really impressive is that he had the clarity of mind to start the APU. Now, this was not part of any memory items. It was not part of a curate checklist. He just did this from memory because he realized the situation that they were in and the fact that they are very close to the ground and they're going to have very little time. And it's going to turn out the fact that he started the APU this early is going to have a huge effect on the rest of the flight. Only 10 seconds later, Captain Sully, who's now the pilot flying of the aircraft, calls for the QRH, the quick reference checklist, to be actioned by Jeff Skiles. And he also sends out a Mayday, Mayday, Mayday message to air traffic control, stating the type of emergency he has and that he's turning back to LaGuardia. The Mayday part, unfortunately, is not heard by ATC because another aircraft is transmitting at the same time. But the fact that this whole procedure, what we've heard up until now, only had taken about 12 seconds, shows a very high level of situational awareness on behalf of the flight crew. Only a few seconds later, Jeff Skiles is starting to work on the checklist. Okay. Now, remember how I told you that Jeff Skiles had just finished his type rating course? Yeah, you can kind of tell that here, because for anyone who has been out of the simulator for a while or has only done maybe some recurrent training every 6 months, it would take a while to kind of get your wits around you and to find the correct checklist. But it only took Jeff Skiles a few seconds. And that's likely because during the type rating course, you practice a lot of different malfunctions and you deal a lot with the quick reference handbook. So he would have very quickly realized what he was looking at, that he had a dual engine failure, and reached for and started actioning the dual engine failure checklist on the quick reference handbook.
Okay,
Now, worth
fair.
pointing out here as well is that as Jeff and Sully are now starting to deal with the consequences of this bird strike, they're still heading away from the airport. And during the subsequent investigation, it was shown that if they had immediately after they realized that they had lost both engines, started a turn back to LaGuardia, they would have had a chance to land on the runway they departed for or runway 13. However, that is not humanly possible, right? The way that we are trained as pilots is that when something happens, you do not react straight away, because the likelihood is that if you do that, you're going to make a huge mistake. The way that we are trained is to fly the aircraft, make sure it's flyable, look at the problem we have, and only react with kind of our backbone reactions if something is required to keep the aircraft flying, right? And this is what the crew is already doing. To think that they would just realize that bird strike, dual engines, turn, that is not possible. In fact, I think that these guys are reacting with lightning speed at this point from all the kind of experience I have from watching people in the simulator, the fact that they, within the first 20 seconds, have gotten the APU started and started working on the correct checklist and gotten a mayday call in is amazing work, all right? But it also means that their options are diminishing. The further away you go from the airport without engines, the smaller the chances that you're going to be able to return. And this is clearly seen because at this point, Sully is now talking to air traffic control. The reason it's Sully who's doing the radio and not Jeff Skiles is that normally when we have an emergency, the pilot who's working on the checklist concentrates on working on the checklist. The pilot who's flying also does the radio if he or she feels that they have the capacity to do so. Now, air traffic control, who knows what's happening, is trying to give options to Cactus 1549. They're telling them basically that all of the runways on LaGuardia is open. Sully is indicating that he probably won't be able to do that. Now, Sully is now most likely weighing in on his options, okay? He knows that the aircraft reached a maximum altitude of about 3,000 feet before it started to descend. He knows that he needs to keep his speed fairly stable, and he's watching out for different things to do. Remember that they are flying over one of the most densely populated areas in the world here, over New York City. And any turn he would do to try to get back to LaGuardia would also force him to fly in over Manhattan, okay? Now, something that you learn during your flight training is that if you have no engines and you're turning, you're losing more altitude than if you're flying straight ahead. Yeah, so true. Sully would know that if he decides to make a turn back to LaGuardia, he's going to lose so much altitude that he will be out of choices then. Right? Either he reaches LaGuardia or he is going to have to land short of the runway, potentially in a very densely populated area. And that is not a nice situation to be in.
Yeah,
in fact, the only thing that he sees is either looking straight ahead, where he sees Teterboro Airport, but realizes quickly that Teterboro is just too far away. It's 9 miles away or so. And then he sees this nice open strip, which is the Hudson River. So at a fairly early stage, you can hear through the communication with air traffic control how Sully is starting to kind of leaning towards going down the Hudson.
Go.
And that is likely because he understands that he doesn't have any other real options at this point. During the descent now, Sully is obviously flying the aircraft, looking out for where he's going to go, and Jeff Skiles is working hard on the checklist. Okay, he's reading through checklist item by checklist item. But something that becomes clear at this point is that the dual engine failure checklist for the Airbus A320 was not made for a dual engine failure just after takeoff. In fact, this checklist was made for what was thought to be the most likely scenario, which is an engine failure or a dual engine failure at high altitude. So it includes things like, increase speed to 300 knots in order to windmill the engines to be able to start them. They have a quick discussion about this. Jeff basically says, He says, increase speed to 300, we don't have that. And Sully responds to, no, we don't. And because a lot of the checklist is based...
Yeah, if you're trying to go through a knot by, like, say, going to a dive, by the time you do a knot, you'll be in the water.
basically not made for the situation they find themselves in. They are going to, or he is going to have to work through the checklist just doing what he thinks that he can do. And this is not a nice situation to be in for any pilot at any point. But what we have to look at here, and something that they do great, is that they keep the roles divided, right? Sully is concentrating on flying the aircraft, looking after a plan where to land, and Jeff is trying to do his absolute best to use the checklist to restart at least one of the engines, because if they can do that, they can get the aircraft flying again and get it back onto a runway rather than into the Hudson. At time 15:29, so this is just about 2 minutes after the engine failure, Sully takes up the PA mic and calls, "This is the captain, brace for impact." Okay, this is crucial because remember, up until this point, there hasn't been any discussion with cabin crew. They would have noticed that something's wrong, that it's gone very, very quiet inside of the cabin, but they don't know how much time they have. But by Sully calling this, they know, brace for impact normally comes just before you impact the water. So it would indicate to the cabin crew that they have a no time available emergency on their hands, and they need to communicate to the passengers to basically just go into brace positions for potential emergency landing. Now, another thing that is worth pointing out here is that during the descent, Captain Sully, who's now probably looking out the windows most of the time, is gradually losing speed. During the subsequent investigation, he stated that he thought that he was following what's called green dot speed, which is a safe speed to follow, and that he only reduced back to the F speed, the foxtrot speed, which is the approach speed, when they had flaps out. But in fact, the speed had been steadily deteriorating all the time as he's now descending. And as they're descending in, they're also getting a lot of different warnings, right? They're getting beeps from the aircraft telling them about the different failures that are being associated with the dual engine failures. But they're also getting a TCAS warning, because as they're now descending in over central New York, there's loads of helicopters around. They trigger some TCAS warnings, but also, crucially, they're getting ground proximity warning systems warnings, GPWS warnings. Okay. Now, if they would have had the ditching checklist, which is a separate checklist, that checklist actually tells them to turn off the GPWS warning system, because they're not supposed to get these kind of spurious warnings that doesn't help them. But since they're reading through the dual engine failure checklist, that is not telling them to do so. And another thing that is really important to remember here is that when the Airbus 320 is constructed, it is constructed to kind of layer different warnings on top of each other depending on how crucial they are. And the GPWS warning is considered to be one of the most important warnings. It's basically telling the pilot that they're about to fly into a mountain. So any warnings that could be sounding at this point is going to be muted by the GPWS warning. So the fact that they're getting terrain, pull up warnings mutes other warnings. And in this case, the speed warning that they would have gotten, that Sully would have had if it weren't for the fact that the GPWS warning system was constantly sounding. So he is now getting lower and lower and lower on speed. Around 15:29:20, so about 2.5 minutes after the initial engine failure, First Officer Jeff Skiles starts to realize that he's not able to restart the engines. He still continues, he still move around the switches according to the checklist, but he's also indicating to Sully that, this doesn't seem to be working. And just about 20 seconds later, Sully asks for flaps, right? Just give me flaps. Jeff gives him flaps. 30 seconds later, Jeff calls out that, okay, you have flaps, and he gives him a speed readout. You have 170 knots, you're 250 feet. Have you got any power? Indicating that, try just to put the thrust levels up, see if any of them would respond, even though it doesn't look like it. Nothing, obviously, is coming out. Jeff then asks, you have flaps 2, do you want more? And Sully responds that no, we'll stay with flaps 2. This was discussed during the subsequent investigation, whether or not this was the right call to do.
It was.
Sully said that he had, in his experience, choosing flaps 3 rather than flaps 2 would just give more drag, and flaps 2 would give him a better kind of nose attitude as he was hitting the water. And that was, agreed to by the investigation committee as well. So at this point, they're now coming very close to the water. And Sully is starting to prepare for the flare. But remember how I told you that the speed was low? Well, it turns out that below 200 feet, they're actually 15 to 19 knots below the SL speed, which is kind of the lowest speed that gives you margin to stall. And remember how I also told you that it was important that Sully had turned on the APU? Well, it turns out that if he hadn't turned on the APU, the only power that the aircraft would have had would have been from the ram air turbine. And if that's the case, the Airbus 320 goes into alternate law. And in alternate law and subsequent direct law, the aircraft will not have the alpha floor protection that it has in normal law.
Oh?
The Airbus 320, if you're in normal law, which is when the computers are, fully functioning, even if the pilots try to stall the aircraft will not let them, right? But if you are in alternate law or direct law, it will do what the pilots tells them. So here, as Sully is now coming closer to the water, he asks Jeff, do you have any ideas? Jeff turns back and says, no, not really. And this is also a show of great airmanship and great CRM. The fact that before, you face anything like this, before you have the ultimate risk of going into the water here, you see, is there anything that we've forgotten to do? Is there anything else that we can do? You're utilizing the crew to its maximum capacity. Now, as Sully is now getting closer to the water, he tries to flare. But because of the alpha floor protection, because the speed is so low, the aircraft does not flare as much as he wanted to. He has the stick all the way back, but it still flies into the water with considerable force. The last thing that we can hear on the CVR is Sully saying, okay, let's brace. The aircraft hits the water with a force that is above the certified landing in water force. And because of that, there is some quite significant damage to the aft part of the aircraft, which is what hits the water first. The left-hand engine gets broken off, but the aircraft continues to just slow down into the water and then settles down. Because there was some quite significant damage to the aft part of the aircraft, the water entered the aircraft there and kind of sinks the aft part of the aircraft down.
At least everyone survived.
In the certification of the Airbus 320, it is supposed to be able to stay afloat so that you could use all of the emergency exits. Because remember, it is equipped with these slide/dinghies in both the forward and the aft emergency exit. Because it's now sinking down into the water, the cabin crew is doing an absolutely amazing work of redirecting the passengers from the aft part of the aircraft, who is now sinking down into the water, towards the overwing exits and towards the front exits. The evacuation over the overwings is going slower than normal because people are not jumping down off the wings that they would do normally. Instead, they're kind of crowding out on the wings. So some of the passengers from the aft part of the aircraft finds their way towards the forward emergency exits and exits onto the dinghies there. Fortunately, there is enough room for all 150 passengers and 5 crew in the dinghies and on the wings. And that's where you have these amazing pictures where the passengers are all crowded on the wings and in the forward part. Now, air traffic control has done a great job as well. They've been talking to the Port Authority in New York, who's been sending out boats. So within minutes, the boats are there, picking up the passengers. Because it's freezing, most of the passengers are wet. And if they wouldn't be so close to these ferries, there is a likelihood that there would have been fatalities here.
So that's good.
Now,
okay,
the flight crew, they are unharmed. After they have settled down into the water, Sully and Jeff goes back into the cabin and actually does a sweep of the cabin to make sure that all of the crew and passengers are out before they themselves leave the aircraft through the forward emergency exits. Now, guys, I cannot overemphasize what a fantastic
This is insane.
feat this is.
This is actually
alright?
insane.
And what I'm going to do is I'm going to summarize this with the end of the NTSB
Insane.
report and what they came to when it comes to the conclusion of this accident. They say, the National Transportation Safety Board determines that the probable cause of this accident was the ingestion of large birds into each engine, which resulted in an almost total loss of thrust on both engines and the subsequent ditching in the Hudson River. Contributing to the fuselage damage and resulting unavailability of the aft slide rafts were 1. The Federal Aviation Administration's approval of ditching certification without determining whether pilots could attain the ditching parameters without engine thrust.
Okay.
2. The lack of industry flight crew training and guidance on ditching techniques. 3. The captain's resulting difficulty maintaining his intended airspeed on final approach due to the task saturation resulting from the emergency situation. Contributing to the survivability of the accident was 1. The decision-making of the flight crew members and their crew resource management during the accident sequence. 2. The fortuitous use of airplane that was equipped for an extended overwater flight, including the availability of forward slide/rafts, even though it was not required to be so equipped. 3. The performance of the cabin crew members while expediting the evacuation of the airplane. And 4. The proximity of emergency responders to the accident site and their immediate and appropriate response to the accident. So, with all of this in mind, the fact that they were flying that aircraft with that flight crew, that cabin crew, on a day that the weather was fine, and that they managed to land on the Hudson River, close to where the boats were, and they were rescued so quickly. I think all of that together really defined why this was called the Miracle on the Hudson.
A name that
Now guys,
earned.
as a result of this, there were more than 30 different recommendations for what needs to be done. For example, there was a recommendation that went out that pilots needed to be trained for these kind of emergencies, low altitude. The fact that there was a possibility to lose both engines soon after takeoff, and basically be trained to be able to do a ditching without engine power. It had not been part of the training program up until now, and that is not only for the Airbus fleet, it went over to us in the Boeing fleet as well. We're also doing this kind of training now because of this incident. There was also other recommendations about emergency exits, for example, about the checklist being harmonized so that, for example, the loss of thrust of both engine checklist would lead into a potential ditching checklist, which would include turning off the GPWS warnings so that you could get the low speed warnings, and many other things like this. And this is a great example on how an incident led to improvements in safety throughout the aviation business.
Alright, now I'm gonna mute and let you listen to this.
Cactus 1549, LaGuardia runway 4 position, hold traffic on land 31.
Position runway 4, Cactus 1549.
Cactus 1549, runway 4, clear takeoff.
Cactus 1549, clear.
Cactus 1549, contact New Departure Track.
Good day. Cactus 1549, 700, landing 5,000.
Cactus 1549, New Departure to contact, climb, maintain 15,000.
Maintain 15,000, Cactus 1549.
Cactus 15.9, turn left lane 270.
This is Cactus 1539. Hit birds, so you've lost thrust on both engines, returning back towards LaGuardia.
Okay, you need to return to LaGuardia. Turn left heading up 220.
220.
Tower, stop your departures, got emergency returning. It's 1529. He bird strike. He lost all engine. He lost the thrust in the engines. He's returning immediately.
Cactus 1529. Which engines?
He lost thrust in both engines. He said.
Got it.
Cactus 1529. We can get it to you. Do you want to try to land 1013?
We're unable. We may end up in the Hudson.
Showing 2760. Turn left 070.
070, showing 2760.
Hi, Cactus 15.9. It's going to be left traffic to runway 31.
Unable.
Okay, what do you need to land? Cactus 15.9. Runway 4 is available if you want to make left traffic to runway 4.
I'm not sure we can make any runway. What's over to our right? Anything in New Jersey, maybe Teterboro?
Okay, yeah, off your right side is Teterboro Airport. Do you want to try to go to Teterboro?
Yes.
Teterboro, Empire, actually, LaGuardia departure guy, emergency inbound.
Hey, got
Cactus 1529 over the George Washington Bridge, wants to go to the airport right now.
wants to go to our airport. Check. Does he need assistance?
Yes, it was a bird strike. Can I get him in for runway 1?
Runway 1, that's good.
Cactus 1529, turn right 280, you can land runway
Bird strike.
1 at Teterboro.
We can't do it.
Okay, which runway would you like at Teterboro?
We're going to be in the Hudson.
I'm sorry, say again, Cactus?
We're looking for the traffic 2 Tango Alpha.
Yeah, 2 Tango Alpha, he's at 900 feet abeam the North Hudson. He's, looks like he's descending into the Hudson River. 2 Tango Alpha, it looks like there's, maybe an incident here.
Roger, keep my eyes out, 2 Tango Alpha.
2 Tango Alpha is 12 o'clock and 2.5 miles.
Got him in sight, maintaining visual.
2 Tango Alpha, roger.
Cactus 15.9, radar contact is lost. You also got Newark Airport up at 2 o'clock in about 7 miles.
Oh, I think he said he was going in the Hudson.
Cactus 1529, if you can, you got runway 29 available at Newark up at 2 o'clock in 7 miles.
60. Going down. 2 Tango Alpha, close roof.
2 Tango Alpha, roger.
In the water.
Roger.
As always, guys, I would love.
So, that was a full flight with ATC. What are y'all's opinion on it? I think it was amazing. The crew did an excellent job. What do you think of this last video before we end off the stream? Hope you all enjoyed it a lot. I'm tired, okay? It's 9:23 p.m. for me. I'm tired. I'm gonna get my boyfriend cast up in a few hours. But that is gonna be it for this stream. Hope you guys enjoyed. If you like what you saw, like, subscribe if you're new or on YouTube. If you're on Twitch, follow me on Twitch if you haven't already. Without further ado, I'll see you next time. Wait, wait, Sully was painted as a bad guy? Wait, why? Before we go, wait. How did the courts paint Sully as a bad guy? How? I need to know this. How was Sully painted the bad guy? He literally was. Everything he did in the flight was amazing. How was he painted the bad guy? Alright. See you later. I'm out. I'm tired. I need rest.